There we go. I'm also going to turn my camera off as well, just to save on a bit of bandwidth. There we go. Right, so first things first, Rhino. I'm going to be using Rhino 7 today. It's the most recent version of Rhino. It's released about 1.5 years ago. I'm just going to quickly show you where to download it for those of you that have decided to join at the last minute. So if you just go to Google, type in Rhino download, click on the very first link, should be rhino3d.com/download, and it brings you straight to the download page. Now, the great thing about this is Rhino is available for both Windows and for Mac. It's an extremely powerful modeler. And I would say for those of you that have, well, for those of you that are looking for a bit of a balance between AutoCAD, Revit, SketchUp, Vectorworks, if you want somewhere kind of in the middle of those, oh, and 3ds Max, sorry. If you want somewhere in the middle of of all of those, I would say Rhino is the one for you. It is an extremely powerful modeler. It can do just about everything. It's actually my favorite modeling software. Out of the 130 odd software that I know, this is my #1. It's the one I use all the time. So hopefully you're going to adopt this one moving forward. And of course, in the field of architecture, it's only becoming more and more adopted. There's so many larger and smaller companies using this now as their main package. It's a fantastic set of tools. So in terms of licensing, currently you can download a 90-day evaluation version. It's actually exactly the same as the full version. It just means you get the license for free for 90 days to try it out, which is very, very nice of them. There is also a buy section. So at the end of the 90-day period, you could go to the buy section and you see that a Rhino 7 license is usually €995. Or if you click on students and faculty, you can get that for €800 discount for €195 total. Now, this sounds like a lot of money still, and of course it is. But the great thing about this is it's a lifetime license. It's not like SketchUp or the other softwares where you have to pay a yearly fee. This means that you have this software for life. You can use it till the day you die. And then after that, if you wanted to upgrade to future versions, like let's say you've been using this one for a few years and in the future, Rhino 8 or Rhino 9 or something has come out, you could upgrade to that for just €95. So again, really, really useful software. Unfortunately, they don't offer an educational system where we can purchase the licenses for you. Obviously, we do have the lab licenses. You'll find Rhino 7 installed on all university computers. We've made sure of that. So you can access those while on campus. And of course, if you're using our remote access LeoStream plugin that you can access through the ADD Moodle page, that means that you can log into the university computers from home using your personal laptop, and you can access the Rhino licenses that way. So again, you don't have to pay for the software. I, of course, recommend you do. After many years of using Rhino, I've finally purchased a license. I've got to say, it is so much better to have a legitimate version. So hopefully once you've gone through this and you've installed it, you should then, well, you'll have the software installed. And I'm just actually going to close Rhino down for a minute. I'm going to show you what happens when we first load it up. Open Rhino 7. So when you first open Rhino, it should open with a window like this while it's loading. And there's a few kind of interesting things going on here. So firstly, you've got your license information. You see that I have a fully legitimate license. I'm not using a pirated one. This is one I've actually paid for. We've got our Open tab, which basically just lets me open other Rhino files. I've got my Recent tab, which allows me to see my recent Rhino files. And then I've got my New tab, which is where I can choose my templates. Now, of course, the nature of what we're working on is typically large, being from an architecture discipline. So I would choose large objects. And of course, because we're in the UK, we're always going to be using a metric system. We're always going to be using millimeters as our smallest measurement. Occasionally, you may need to go smaller than millimeters, in which case you can just type it in as 0.1 for 0.1 millimeters, etc. The only exception I would say to using millimeters is if you're a landscape student. So depending on the scale of your project, you may be working in meters. Those are the only two I would ever use, millimeters and meters. So millimeters for architecture, meters for very, very large landscape projects. I would never use any of the other ones. Just while I've got this panel open, I do just want to quickly mention this section on the right. So you've got the little news section here. This is actually really useful. It tells you about upcoming courses, free webinars, all sorts of stuff like that. It's always ways that you can continually improve your Rhino usage. So a lot of people do tend to just skip past this without checking it out. You know, even this one, Become by Arturo Tedeschi. Arturo Tedeschi is like the father of the Grasshopper plugin. For those of you that don't know Grasshopper, don't worry, we'll be covering that in a couple of weeks. But Arturo Tedeschi basically wrote the Bible on Grasshopper, and you can access all this stuff for free. So again, it's fantastic. There's also a section down here for tips. These are essentially very short videos a lot of the time, or they might just bring you to a web page to show you how specific commands and tools function. And again, this is actually really useful, especially after updates, because sometimes they'll change the way that things work to improve the system. And they'll say, we've changed this, have a look at how it works now. So it's a good way to keep up to date. Now I'm going to shut up about that. I'm going to choose a template. I'm going to choose, go to my new tab. I'm going to go to large objects and millimeters. And for those of you that missed that pop-up window, and if you're thinking, oh, I'm not sure which template I'm in, you can just click on File, go to New, and you get the exact same templates just there. So large objects, millimeters, click Open. Just gonna have a sip of my coffee. Yeah, that's better. So hopefully everyone now has Rhino 7 open. If you're using an older version of Rhino, for instance, if you're in one of the older CAD labs on campus today, you may be accessing via Rhino 6 or Rhino 5. There are some significant upgrades in Rhino 7 that you won't see in Rhino 5 and 6. The biggest one would be the sub-D tools. Now, I'm not going to start with the sub-D tools, but I do just want to mention this extra drop down here at the top. So this one's for the special sub-D tools. Again, it's native only to Rhino 7. So if you're working on an older version, you won't see these. Don't panic, just upgrade, you'll be able to access them. Fantastic tools. And again, I will be covering some of those today. Right, I think we're ready to start. So I'm aware at first that some of you that are using Mac, your interface is going to be slightly different. In fact, I will get an image up on the screen of the Rhino Mac interface, just so we can talk through the differences. Probably should have got one of these up in advance. Yeah, that works. Open image in new tab. Right, let me just talk through the Rhino one first. So first and foremost, we've got 4 main viewports. So by default, this is in third angle orthographic. So that means that our top left viewport here is in our top view. Our front viewport is in front. This one down here is in right. And each one of these 3 is viewing it orthographically, so there's no perspective distortion. The one up in the top right gives us a 3D view of our object, meaning we can view it with perspective distortion. So I'm just going to quickly drag out an object. Again, you don't need to do this. I'm just quickly showing you an object, just to kind of show you how these views work in relation to each other. So for instance, we've got our top view, front, right, and perspective, yeah? And the cool thing about this is I can move this in one axis and you can see it updating in the others. And I would say this is where Rhino excels so much higher than a lot of the other software, because you can work both orthographically and in perspective at exactly the same time. It makes it much easier to see what directions you're moving geometry in. Now again, I'm not going to worry about that too much just yet. I'm just going to reset that back to how it was. We're going to make some geometry shortly, so again, don't worry too much. But yeah, so that's our top, front, right, and perspective views. You will see that you can click on the drop down of these views, and you can actually change some of these settings. So we are going to go through these again separately in a minute, but you can change the visual style. So you might have seen me a minute ago change from wireframe to shaded, so I can actually see the 3D object. There's a bunch of other ones there that we'll try out shortly. And if we go further down, there's also an option for set view. And this allows you to change from the standard views that we're currently set. So let's say, for instance, this top view, maybe I wanted to change that to viewing it from underneath the object. I could click on that, go to set view, tell it to go to bottom, and now I'd be viewing that object from underneath. Now I actually don't want to do that. I'm going to set this back to top. Again, top, front, and right is your standard third angle orthographic. So that's why we're going to be using that one. Right. All of that so far is exactly the same in Rhino, Rhino for Mac, sorry. The only difference is there on Windows 7 or Windows 10 even, you can click on the little drop down and choose maximize. And this allows you to full screen one of those views. So for instance, I've just full screen the perspective view. Now I could click the drop down again and click on restore, and that would restore it back to my 4 viewports. On Mac, it's slightly different. On Mac, you've got, if I can remember where it is, yes, it's a bit hard to see. It's a little bit pixelated, this image. But essentially, just above these viewports, you've got this bar, and you've got a little icon that looks like 4 squares and another icon that looks like a single square. This is basically how you navigate between making a viewport full screen and making it back to 4 separate viewports. So again, Mac users toggle those, Windows users, you right click, you toggle between full screen and minimized. What other differences are there? Over on the left, we've got our tools. Tools are extremely useful. And what you'll come to find with Rhino is that there's actually a bunch of different ways we can use it. So you could use these tools over here on the left. For instance, this one here is the Polyline tool. So I could click on the icon, I could draw out a polyline. Or I could type in the command Polyline. So I'll just start typing, hit enter. I could draw the same shape. Or I could click on the drop down where my curves are, and I could also go to Polyline and make a polyline. So again, there's so many different ways that you can make and use the exact same tools. It's a very flexible software. I think this is why so many people love using it. So 3 main ways to use it there. Again, we are going to be playing with some of these tools in a minute. We'll go through them in a bit more detail. Some of you may have noticed as well that I've got all of these kind of tabs across the screen. Might be slightly different on a Mac. Again, I wouldn't worry about it. And you might notice that I might have a few extra ones like Enscape. You probably won't have those by default. Enscape is just an extra renderer that I've added into my Rhino 7. So it means that once I've finished modeling my projects, I could click on my Enscape that I've installed, launch it, chuck on a load of materials, set up my lights and cameras, and I could bang out some really nice photorealistic visuals. So again, not something you get as standard, but you can install it for free. Just talking about interface still, just above our main viewports and above these drop downs, you'll see that we've got the command line. Now, command line is very, very, very useful, especially when you're first starting out. So I mentioned about typing in commands. You could click in where it says command and start typing. But even if you're working out over here, let's say I've clicked a few times in my perspective view. If I start typing in box, you see it automatically types my command into the command line. So you don't always need to click on command. It will just type in there as you type. And in fact, if I hit enter to say, OK, I want to use my box tool, you see up in the command line, it's also giving me my instructions. So it's saying, OK, you want to make a box, specify the first corner of your base. So I'm like, OK, I'm going to click to specify the first corner. Now it's saying specify the other corner. So I can say, OK, I'm going to move my cursor around. It's obvious what the other corner is. It's the opposite corner. So I've specified that. Now in the instructions, it's saying height. Press enter to use width. Now that's a bit confusing, but I can see that I can move my cursor in a different view to set my height. So it's slightly different from SketchUp in that you don't need to draw a rectangle and then push and pull, for instance. You can go straight to making 3D geometry this way. You could also use it the same way if you wanted to. You know, I could use the rectangle tool and then I could extrude it up. That's another way I can make a box. But yeah, I just kind of wanted to show that as an example, just to show you how that command line's working. I promise you we are going to actually start making some stuff in a minute. I'll show you how to use it properly. Over on the right, we've got our kind of properties panel. Even though it's not just for properties, it's also where we've got layers and materials and things. But I always just call this the properties panel. And what you'll find is that when you select an object, If you're on the Properties tab, which is this colorful wheel, you'll see it gives you all of the information about the object you have selected. So for instance, it's telling me that the type of object is a closed extrusion. So it's a rectangle that's been extruded and it's watertight. There's no open edges. I could give the object a name if I wanted to, although I don't think anyone actually names Rhino objects. It tells us what layer it's on. It tells us what color it is. It tells us how thick the line types are, and so on and so forth. It's really, really useful. Now, I'm not going to talk about the sub properties just yet. This is a bit more advanced, and I might get onto this a bit later in the session if we have time. Particular one that may be interesting to you in the future is this one just here. In fact, if I click it, there we go. So this one just here is your texture mapping when you're on properties. Texture mapping is how you can resize your materials and how to adjust the fit. So again, really, really useful. I can see there are some questions popping up in the chat. I'm going to answer some of those shortly. The next tab is layers. So again, for those of you that are coming from AutoCAD, for instance, hopefully you'll be used to working with layers. It's good to be really organized with your documents, of course. And you can imagine if we're doing an entire 3D model of a building, let's say I've got a full set of floor plans, I've got extrusions for my walls, I might have some furnishings, you know, having all of that on a single layer is just going to be a nightmare to work with. So it's important to be able to make layers and to disable them. And in fact, if I drag this window out, you see you can also set common settings for layers. So for instance, I could say, okay, any object on layer number 1, maybe I want to change the line type, maybe I want these to be dashed, and maybe I want them to be really thick. In which case I would just click on these. So for instance, the line type one I just clicked on, I could change this to dashed. I could go to where it says print width. I could change my thickness of the line. So again, it's actually super, super easy to use. The cool thing as well with this, of course, is if I wanted to move an object to another layer, I could select my object, right click on the layer I want to move it to, for instance, layer number 1. I could click change object layer. And that means that object is now turned red because that layer is the color red. If I were to print this drawing off, the line work would be dashed, and so on and so forth. And of course, there's a little light bulb icon for you to turn the object on and off, or the layer on and off, I should say. So I think it's relatively straightforward. Again, if you're coming from another software such as AutoCAD, you should be familiar with this. It's the exact same kind of system. But if not, it's just something you need to play around with. If you're on a Mac, by the way, if you can't right click and choose change to object or change to layer, I believe you can select your object, right click there, and choose move to layer, if I remember right. If not, I think they have changed it now, but if you're using an older version, you might just need to right click the object to change that on a Mac. There is one more tab that's going to be useful over here, and that's the materials tab. And again, relatively straightforward in how this works. You've got a little plus button to create a new material. You do have the option to import from material library. And this gives you all of your default Rhino materials, some of which are good, most of which aren't very good, to be honest. If I click on architectural, maybe I want to look at floor textures. Maybe I want to look at wooden floors. If I just change my view to large icons, you can see I've got a bunch of different wooden floor materials that I can now add in. So I'm going to click OK. This gives me all of the material settings. So for instance, I've got the material name, I've got its texture there, its color, which makes it have that wood appearance. If I wanted to assign that to an object, I would just select my object, right click the material, choose the first option, assign to object. So now that object would have that material applied. We currently can't see that material. The reason we can't see it is because our viewport is still set to wireframe. So again, I'm kind of jumping ahead of myself a little bit. I don't want to complicate this too much. I just wanted to talk to you about applying materials while we were there. But essentially, if I put this into rendered mode, you'll see I've got my material applied to my object. In fact, if I just undo it, if I were already in rendered mode, for instance, I could select my object, right click my material, assign to object, and that would allow me to see my object in full. Now we've got a couple more things to talk about regarding the interface, and then we're ready to start making some stuff. So final things to talk about would be the drop downs at the top. Drop downs, of course, are going to be really useful. It's where you can make new documents, you can open, you can save, import, export, etc., especially under the file drop down. Now I just want to talk about importing. This is where Rhino really excels above most other packages. Rhino can support just about every file type. It is absolutely fantastic. So for instance, if I go to File and Import and click on the drop down, you'll see that I don't need to export most of my other files. I could just import them in from the native file type. So 3ds Max, we've got Illustrator, AutoCAD, MicroStation, OBJ files, which are really common. You can import PDFs as well. What else we got? SketchUp, we've got SolidWorks, STLs, loads of different types of files that you can just import in. Now I do just want to quickly mention the PDF one. If you've been lucky enough to find a PDF of like a floor plan, for instance, and if that PDF is a vectorized PDF, if it's been saved from a CAD package, when you import that into Rhino, it will automatically convert that to Rhino geometry. It's absolutely fantastic. Saves you having to manually trace your files. I'm aware AutoCAD can do the same thing, but the problem with AutoCAD is that when you're working with much larger PDFs, like really dense, complex PDFs, it will tend to take a couple of hours to process. Whereas when you bring the same drawing into Rhino, the same PDF into Rhino, it will convert in about 20-30 seconds, something like that. You could then also export that resulting Rhino file as a DWG and open that in AutoCAD. So again, it's a really good conversion software for things. And likewise, if I wanted to convert one software into another, if I couldn't find a software that could open it, chances are Rhino is the one that would be able to do it and convert it for me. Yeah, that's better. So I just wanted to mention that first. Again, I find that extremely useful. Rhino can just convert anything. Under the edit dropdown, again, we've got tons of usual stuff. So undo, redo, etc., copy, paste. This one here is particularly useful, select objects. So when you start working on really complex models, you're probably going to want to be able to quickly select things. So for instance, for those of you that have ever used the Digimap service, let's say you've downloaded a vector map of your entire site. And in that map, you might have some hatches to represent shaded areas like green and greenery and pavements and building plots and stuff. You might have some text objects. You might have some curve objects to represent vectors, and so on and so forth. If I wanted to just select all of the text across my drawing, sometimes, especially with Digimap drawings, there's thousands of pieces of text. A very quick way to do that would just be to go to Edit, Select Objects, choose Text, and that would select all of the text in my scene. And likewise, if I were to select all of the hatches, maybe I've got a really slow file that I just want to optimize, especially from Digimap. I could go to Object or Edit, Select Objects. I could go to Hatches, wherever Hatches is gone. There we go, Hatches. So I could click on Hatches, and that would select all of the hatch objects. And then I could just hit delete to delete them out, or move them to another layer. So again, it's a fast way to work. Saves you having to manually go around and select everything. And I believe that's something that AutoCAD can't do. I understand AutoCAD has the command select similar, but it doesn't work anywhere near as well as this. And of course, there's also the option to select duplicate objects. Now, again, if you're sending something for laser cutting, for instance, it's very important that you don't have any duplicate curves, any duplicate line work, because otherwise the laser cutter would travel over that same line multiple times, yeah? So if you remove duplicate objects, it just ensures that you're going to have nice, clean, flat line work. Whew. We're nearly there with the interface. View dropdown, again, this is really similar to what happens when you right-click on a perspective. You know, you can change between the visual style, you can set a view, so on and so forth. And then we move on to the important dropdowns. So we've got 4 main dropdowns. These are going to be curve, surface, solid, and mesh. You see I skipped sub D for a minute because sub D is the newer tool palette. So curve is where we can make curve geometry. So things like line work, like technical drawings. They don't have to necessarily be 2D. We can manipulate curves in 3D and create objects from them. I'll show you how to use that today. We then got the surface dropdown. This is where we can create essentially 2-dimensional and 3D objects that don't have a thickness. So they're open objects. They don't have an internal volume. It's almost like a piece of paper, for instance. I know a piece of paper has a thickness, but hypothetically, let's pretend it doesn't. Solid objects are objects that have an internal volume, so they're not open objects. They're completely closed. And essentially, this means that they're what we call watertight. So I could fill the object with water. If I were to turn it all around, it wouldn't leak anything because there's no open edges. So this is where we use the solid dropdown. And lastly, we have mesh. And mesh is where things get confusing. I'll show you the difference between surface, solid, and mesh in a minute. But mesh essentially is a different type of modeling to curve, surface, and solid, and sub D. Mesh is its own thing. It's where we're working with polygons to make 3D objects. The other ones are what we call NURBS objects. In fact, does anyone know what NURBS stands for? Does anyone want to type in the chat? I'll give you 10 points. Not that there's a grading system, but 10 points for anyone who can tell me what NURBS is. I wouldn't expect most of you to get it. So NURBS stands for non-uniform rational B-splines. So again, I'm not sure most of you are thinking, what the hell does that mean? It's not something that you really need to remember, but the key word to think of there is the word spline. Now, some of you may be familiar with splines, curves, and polylines. Essentially, it just means that it's a type of curve. So I'm going to bring an object onto the screen now. I'm going to just bring my torus on the screen. I promise you in about 2 minutes, we'll start making stuff. So let's say at the moment, I've got this object. If I just make this full screen. The way that this object works, this NURBS object, is that it's using these NURBS curves to define the object. So for instance, we've got this line running over here. This is a NURBS curve. And we've got those running around the object. We've also got NURBS curves running around the horizontal plane as well. So what this is essentially doing, it's saying, right, between each of these curves, like what we can see in wireframe, between each of these curves, I want you to fill this with a surface. I want you to patch them together. And what it does is it reads those as instructions and it builds that surface. Now, I'm just going to make a mesh version of this. So it's slightly different. We've got our NURBS object here where it's using the curves. Our mesh is actually slightly different to this. So mesh, we use polygons. So each individual kind of polygon, or each area has a boundary, I should say. And each one of these is its own separate thing. And then they're stitched together to make one big object. So that means that, for instance, I could delete some of these faces. I'll show you how to do that properly later on. But I could select these individually and delete them out. In fact, you can even go inside the thing. It's kind of cool. Reminds me of that episode of The Simpsons where, you know, the Halloween special with the time travel. Yeah, you might remember it if you're a Simpsons fan. But yeah, so essentially that's the difference between NURBS and mesh. I'm sure some of you might be thinking, okay, why do I need to know this? It's extremely important to know because it basically affects the way that you model. So for instance, if I wanted to 3D print something, if I were to 3D print an object, typically I would be exporting my object as an OBJ or an STL file type because that's what all 3D printers can accept. And when you do that, it will convert your NURBS object into a mesh object. So it'll be converting your nice, clean, curvy object into something with polygons. So that's one reason that you might need to know about it. Another reason would be simply about resolution. So for instance, a NURBS object essentially has an infinite resolution. So our curve basically doesn't have a set number of control points. This will generate a really nice smooth surface no matter how many times I scroll into it. Whereas I'm just going to quickly make a few different versions of this from a mesh. So I'm going to make a really dense one. Let's just drag that mesh out. I'm going to make a medium one, somewhere in the middle. Can be a bit tricky to select sometimes. Hate it when it does that. There you go, it's my medium one. And then I'm going to make a super, super light one. There we go. So there we go. So we've got a few different versions. So the NURBS object is always going to have this infinite resolution. No matter what scale I make this, no matter what I do to it, it's always going to have super clean curvature. I've got a high polygon mesh, and this gives it a really nice smooth surface. But the problem with this is that the file size is probably going to be quite big because it needs all of these polygons to define the object. Whereas the original only needed 8 curves to define the object. I think it's 8 curves. The medium one, the medium mesh, this is much more like it. It's a good balance between the two. So for instance, pretty decent curvature. We're just about seeing it starting to facet edges, but it's not too dense. This is a reasonable one. It's a good resolution. Whereas the lowest resolution one you see is really jagged. So this obviously wouldn't be a good object. If I wanted to render this, for instance, it's going to look like crap. It's going to go really jagged. If I wanted to 3D print this, again, it's going to look really faceted when I 3D print it. So again, just something to kind of think about, like when you're exporting your meshes. Now, there are benefits of using both. So for instance, if you're making relatively simple objects, chances are you're going to want to use the curve, surface, and solid tools, because this is going to give you nice, clean, light geometry. But as soon as you start cutting into this and making this more complex, it has to basically try and calculate each time how it's going to build the object from X amount of curves. So that can actually start slowing the file down if you make really complex NURBS geometry. And likewise with meshes. If you have really dense meshes, you're going to have large files. If you have smaller meshes, you're going to have tiny files. So that's something to take into consideration. But the good thing is that I can make a really complex object that doesn't use many polygons. So that would keep the file size light. So it's a bit of a fine juggling act between the two. The final thing I'll say about curves, surface, solids, and meshes is just simply that the meshes, they're very easy to repair. So for instance, let's say I had a hole in my, my NURBS object. This one is actually really difficult to close. So if I had like an open edge, I'm not going to do it right now. If I had an open edge, essentially it's really difficult to close that on a curved surface. You know, I'd have to manually draw in some curves. I might want to patch it, so on and so forth. If I had a mesh, if I had like a couple of missing polygons, I'll show you this one actually, just because this is useful. Let's say I've got a bunch of missing polygons. You know, rather than drawing these in as individual faces and joining it together and so on, I could just select my whole object. And in my properties, you see it tells me it's an open mesh. And because I'm working with a mesh object, I would use the mesh dropdown. I want to repair it because it's got some holes. I can just tell it to fill all of those holes. And you see it's putting these little triangulated surfaces in there, but essentially it's patched them, you know, it's fixed those holes. So this is particularly great if you're going to be doing something like 3D printing or CNC machining, or even if you're just doing some visualization and want to just close stuff off. This is really, really useful to know. It's a very fast way to fix your meshes. So that's looking at the interface from the perspective of someone who's not going to be using Rhino for modeling, but just wants to quickly use it for fixing things. The final part of interface before we model anything is just to talk about the controllers down the bottom. So again, this is going to be slightly different if you're on a Mac. The first one I'm going to talk about is the object snaps. So let me just delete these objects. In fact, let me bring up my top view. So first thing to talk about is the object snaps. If you're on Windows, your object snaps will be along the bottom left just here. If you're on a Mac, it is slightly different. You have them running down the left edge just there. And I would say that if you're on a Mac with a relatively small screen, you might not be able to see your snaps, in which case you want to just drag the edge of your tool palette out towards the right. And that's going to allow you to condense your main tools that are above it, and then to have your snaps appear underneath. So again, just drag this palette out towards the right, so it's a bit wider. You should then be able to see your tools above, your snaps underneath. Forgot to mention earlier about the command line for Mac. For those of you that are on a Mac, your command line won't be at the top. Your command line will appear over here just on the left. And as you start using your tools, that command line will disappear and it will give you your instructions there. So same kind of principle as on Windows. I think apart from that, it's more or less the same. I don't think there's a huge amount that's different. The only other thing that's different is this next section. So for instance, on Mac, you got these options along the top just here, where it says grid snap, ortho, planar, etc. For those of you that are on Windows, those are going to be along the very bottom just down here. So a bit hard to see my mouse, but grid snap, ortho, planar, O snap, etc. You see I can toggle my object snaps on and off very quickly that way as well. Now, I just want to quickly show you what some of these things do before we start drawing. Let's say, for instance, I have a rectangle. And let's say I wanted to draw a line coming off of my rectangle. Currently, I don't have any of my object snaps enabled. So when I'm trying to draw a line, if I wanted to draw from the edge of that, I could click on it, try and draw away from it. And it kind of looks like I've done a decent job. But you see that when I zoom in, oh no, I've done it wrong. It hasn't snapped to it. So ideally, we want to try and resolve that kind of thing early on. And that's where snaps come into play. So again, really similar to AutoCAD and SketchUp. In fact, just about every software will have a snap palette. But the great thing about the Rhino one is you can change the way the snaps work as you're using it. So for instance, in AutoCAD, you would need to type in the command osnap to bring up your snap panel and toggle on and off whether you want to snap to endpoints, nearest points, midpoints, centers, etc. In Rhino, you don't need to do that. So for instance, let's turn that off a minute. Let's say I'm using my polyline. I have no idea what I'm drawing, but let's say I wanted to snap to the edge of this bit over there. Let's say I wanted to snap onto this, and I've just realized, oh no, I've done all this drawing and I can't snap to it. I could just come down to my snaps, click on endpoint, and now I can snap to the end. And you see when I hover over it, it tells me it's going to snap to the endpoint. And I could just hit enter to finish my curve. Likewise, if I wanted to snap to the middle, again, I could bring up my polyline. I could click on my mid, hover over the middle, and I could draw exactly from my middle point. So it's a very, very, very fast way to work. Fantastic set of tools. You see more snaps there as well. So we've got our center snap to snap to the center of an object. It's not just the center of a circle, it will snap to the center of any closed geometry. You can snap to where there's like an intersection. So let's say, for instance, I've got two objects that overlap. I now wanted to draw a line from where this intersection is. I can disable the others. Click on int for intersection. And now I can hover my mouse over it, and you see it will say int. So really, really useful. Just going to delete those. Final things would be ortho. So by default, without ortho on, when I'm trying to draw a polyline, you see I can draw at any angle. If I was to enable ortho, it will constrain it orthographically to my north, east, south, and westernmost points, or along my X and Y axis. We've already played with OSnap. You don't need to play with Planar just yet. This essentially just forces your drawing to be on a single plane. So for instance, 0 on the Z axis. This is particularly useful when you're working on 3D objects later on, but we're not going to play with that just yet. I just want to talk to you about Gumball and Smart Track. So let me toggle both of those off at the moment. Let's say, for instance, I've got a rectangle. And let's say I want to draw another rectangle out to the side of it. Now, if I wanted to try and trace these edges, in fact, let me just turn these on. If I were to draw it so it's the same height, for instance, currently I could snap to it. I could try and match it as best as I could. I could move it away. But the problem with that is you see it didn't actually match it very well. So I was able to snap to that top edge because I had to define that other corner. You see I didn't do a very good job. Firstly, because I didn't type in any measurements. Now, one thing we can do is enable Smart Track. So if I try and draw it this time, I could start my rectangle. I could hover over that second point. And now when I bring the cursor out, it brings up these smart guides. So it allows me to snap along it to keep things in relation to each other. So that's really useful. In fact, I don't even have to click on that first one. I could hover over the first point, drag my cursor out, hover over that second point, drag my cursor out. And again, it's just nice to use as guides. I'll do the same thing with this. Ah, crap. Paused it up. Let's try that one again. There we go. So again, Smart Track can be really useful. It can be really useful at the beginning of a project. If you've got a really complex floor plan with lots of complicated geometry, let's say, for instance, you're doing an entire floor plan of a building, you've got tons of furniture, basically just everything in there. Essentially, that means you're going to have tons and tons of smart suggestions, and that's going to make your drawing an absolute nightmare to work with. So if you've got tons and tons of geometry, it's going to be trying to guess what lines you're trying to draw off, especially if you've got millions and millions of curves, in which case, at that stage, you probably don't want Smart Track on. Unless you're isolating objects, you know, it might still be useful, but typically with more complex drawings, you won't be using Smart Track. I can see there are more questions coming up. I will answer them in a sec. Now, the final thing before we start drawing is going to be Gumball. And this is where we get into navigation. So Gumball is really useful. So let's say, for instance, I select my object, yeah? Let's say I've got my rectangle selected. Currently, I can't see any controllers to move this around. And that's because I don't have my Gumball enabled. I mean, I could still try and click and drag this and it would move it around. But if I enable my Gumball, you see it comes up with this red and green kind of arrow and some extra little controllers. And the great thing about this is it means I can just select my object, drag these arrows, and I can move my object around. So it's really easy. I could click and drag on that little blue curve, and you see I can rotate that around. If you have ortho mode enabled, by the way, you'll only be able to snap to 90-degree angles. If you hold shift, it will temporarily disable it. Or of course, you could just turn off ortho, and that would allow you to rotate freely as well. And then the cool thing about this, on the opposite end of the arrows where we can move it, we've also got a stretch tool. So if I click on the little box at the opposite end of this green arrow, you see I can stretch it equally in both directions. So it's a good way to quickly deform objects. And in fact, you know, if we do that with a 3D object, if I bring back that torus again, let's say something like that. You know, I could easily quickly stretch this. So let's say I want to stretch this object out. Not quite sure what I'm making with it. Maybe I'm going to make like a link or something. It's going to be very quick and easy. Let's turn ortho on. Let me just copy and paste that. I could use my rotate tools. So now I've got two objects. Then it's just a case of copying and pasting these along. Or something like that. So not the nicest looking chain. I could have spent a bit more time and probably have stretched that a bit less. But as you can see, you know, complex geometry super quickly. Just by making a single object, stretching it, copying, pasting it, and rotating it. So I will let you play around with those in 2 secs. But yeah, I just wanted to show you what that Gumball tool does. Now, I'm sure you're all itching by now to start actually modeling some stuff. So I think that's what we're going to do now. We're going to start looking at the tools and how you can start using them. So first thing I would recommend to do is to set your top view into full screen. So I'm going to right click on where it says top, up in the top left. I'm just going to go to maximize, or of course, if you're on a Mac, you're going to click once in the top view and then click on the square just above it. That will full screen it. Now, what I want you to do, I want you to explore each of these tools over here on the left, these ones that just look like 2D curves. So polyline, control point curve, circle with a center, ellipse, arc center, and rectangle and polygon. I want you to explore some of these. And as you do, I want you to have a look at what is instructing you to do in your command line. So for instance, I've clicked on polyline, and this is going to answer the first question from Ellie about measurements. I've clicked on my polyline tool, and it says start of the polyline. So I could click to start my polyline. And now it says next point of polyline. So if I wanted to type in a dimension, I'll just go ahead and start typing it in. I already know what units I'm working in because I set that with my template. I told it large millimeters. So if I want to make this a meter long, I would type in 1000. And then to OK that, I just hit enter. And now that's constrained that line to be 1000 long. And at the moment, I just need to click to place to decide an angle. So I'm just going to click to place there. Maybe I want the next line to be 3000. In fact, I don't want my ortho mode on. If I want my next line to be 3000, I could type in 3000, hit enter, and you see it's constrained that line to be 3000. And again, I could hold shift to constrain it orthographically. So it's quite a fast way to quickly draw things out. And what you'll find with each of these is each tool is going to work slightly different. So for instance, my circle tool, currently it's asking for the center of the circle. So I'll click to define it. Now it's asking me for the diameter. If I wanted to change the way that it's asking me to work with this, so for instance, if I didn't want to type in a diameter, maybe I want to type in a radius. I could click on radius in my command line, and now I could type in the radius. So maybe I want a radius of 500, hit enter, it's now defined my object. And you can define that by circumference, area, etc., whatever you want it to be. So I'm going to give you 5 minutes while I quickly go grab a bottle of water. I want you to start playing with those tools, and any problems that you run into, I want you to type them in the chat so I can address them when I come back. And I'm expecting a lot of you are not going to like control point curve. I think some of you are going to have issues with rectangle. I'll explain why when I come back. See you in a few minutes. Right. Hi, everyone. So I'm back again. Hopefully everyone's had a chance to explore some of those tools. Does anyone have any questions for me at this stage regarding the 2D tools? You can either type in the chat or you can unmute and shout out. Happy for you to shout at me, that's fine. I can see there was a question in the chat. What's the difference between planar and project? Planar essentially lets you draw anywhere on a single plane. So I'll quickly show you what this does. It's a bit more complex, but just to show you what it does. Let's say I've got a 3D object. If I wanted to draw from one of these corners, and if I didn't have planar enabled, when I'm drawing from above, let's say I wanted to draw out from a corner, you can see that I can snap in my top view, but I don't know if that's going to snap from the top or the bottom of the object. So essentially what I could do, I could, for instance, if I wanted to draw like a roof on it for something, I could click over here to define that I'm drawing on this plane. And then when I enable planar, this just basically conforms it to snap to that plane. So it will stay at that set elevation, something like that. Now, the reason that's important is if I didn't have planar enabled, just turn that off a minute, I could start drawing on my plane over there. And as you see, I start drawing it out in my top view, and it all looks exactly the same in my top view. But you see in my side view, it hasn't kept it on a single plane. What it's done is projected it down onto 0 on the z-axis. And this is quite a common issue for people that are quite new to 3D. So planar just forces it to stay on that single plane on the z-axis where you started. Turning it off will allow you to be able to draw on multiple planes. Now project is slightly different. Let's say, in fact, let's do a more complex object. Let's use a sphere. If I had an object or a curve or a shape or something I wanted to project onto this, let's draw some shapes. If I draw something in my top view, I'm just going to do some squiggles. Something like this. I'm not quite sure what I've drawn. If I just move this above the object so you can see it, you see what we got. We got a 3D object and we've got a curve. What I can do with project is I can project that curve to sit down onto this sphere. So I'll type in the command project. I select my curve and hit enter. Select my object and hit enter. And it projects that curve onto the object. So that's the difference between those two. Hopefully you find that useful. Right, another question. When I'm drawing a circle, how can I change the setting of the radius to diameter, orientation, circumference, etc. at the command section? It should just be a case of clicking on it. So for instance, when I'm making my circle, it's asking me to define the center of my circle first. And at the moment, you see I can't choose radius and diameter, etc. So I can click to define my circle. And only now, once I'm defining its second measurement, that's where I can choose diameter and orientation. So I would just click on that, click on one of those tools like radius, diameter, circumference, whatever you want to define it as, and that's where you can change it. On a Mac, again, you get all of those options over here on the left. They should automatically change as you work on the drawing. Right, Noor said, sorry, I missed the part where you made the 4 perspectives fit in one page. That's fine. We can change that. So for those of you that want to full screen something, if you're on Windows, it's just a case of right clicking on the name of your viewport and clicking on maximize. That will enable you to turn your 4 viewports into one. And again, if you want to get back to having a single viewport, just right click on the name again, go to restore. Or if you're on an older version of Rhino, it might say minimize. For those of you that are on a Mac, again, it's just over here up in the top left. It's a little bit difficult to see, but just above your top viewport, you got one that will maximize it, which is the one big panel, one that will minimize it, which is the 4 small panels. Have I missed anything else? Nope, I think that's all the questions for now. I'll do another minute or two of questions if anyone has any. And then I'm going to talk to you about the common issues with the curves. Promise you we're going to get to some really cool 3D modeling stuff in a minute. How do you orbit easily? Oh, fantastic question. Thank you. I'm so glad someone has asked. Really, really good question. So let's say, for instance, I've got a 3D object. It doesn't have to be 3D, but I'm going to show the 3D just to kind of illustrate this. If I've got an object at the moment, this is going to be really tricky to navigate. Yeah, it's going to be quite tricky to orbit. Now, there are a couple of magic commands that you can do. But before I talk about that, I'm going to talk about the mouse controls. So hopefully everyone is using a mouse and not a trackpad. For 3D work, you always want to use a mouse. I did my entire BA degree using my trackpad on my MacBook Pro. This was like many years ago. Did my entire degree using a trackpad, and I was a ninja with the trackpad. As soon as I went to practice, I was forced to use a mouse on my first day, and within an hour or two of using it, I was absolutely hooked because it's so much easier. You can get a cheap mouse like a Logitech M185, Logitech M220, one of those. You get those for under £10 on Amazon, and they're absolutely bulletproof. Mine's fallen off my motorbike. It's fallen in a pint of lager. The batteries tend to last a year, and like just on a single AA, they're fantastic little mice. I'm happy to drop a link to those in the chat if anyone needs one. Anyway, back to navigating. So if you have a mouse, you can use your scroll wheel to zoom in and out, which is pretty quick. Left mouse button enables you to select objects. Right mouse button, when you hold it, enables you to pan in your orthographic views. So your top, front, and right, and it enables you to orbit in your perspective view. Now, the interesting thing about this is it's going to orbit around whatever's in the middle of your screen. And sometimes you're going to like that, sometimes you're not going to like that. But let's say, for instance, if I've zoomed out over here, if I'm trying to orbit, that's going to be a nightmare trying to zoom into my object. I could try and zoom in to get it in the middle and orbit around, but it still doesn't quite feel right. So what we can do is we can select an object, and we can type in a command to set our focus to the object. And that command is going to be ZSA. And I highly recommend everyone makes a note of that. It is the most useful command in Rhino, ZSA. It's actually this command just over here. Yeah, it's under Zoom. If you go to View Zoom, you'll find you've got Zoom Extent, Zoom Extents All, Zoom Selected All. And you'll see as well in these drop downs, it does tell you the keyboard shortcuts for these. And if you know the name of it, you can type them in. But it doesn't tell you the shortcut for Zoom Selected All, which I find frustrating because it's so useful. But the shortcut is just the first letter of each one, ZSA. And what ZSA has done, if I just do that again for anyone who missed it, what ZSA does, it will zoom selected all on all 4 viewports. So ZSA, hit enter. It has zoomed in on all 4 viewports to my object. It's centered it. And it means that I can now use my right mouse button to orbit around. And it's going to completely focus on that object. And this is going to make your life so much easier. And I would say that's the reason why a lot of new people don't like Rhino, because they can't orbit around easily, because they don't know about ZSA. As soon as you know about ZSA, you're not going to use any other package again, pretty much anyway, unless you absolutely have to for some reason. But as far as I understand, I don't think any other software can do that. It's just fantastic. The other one that's useful to know as well is ZEA, which is Zoom Extensal. Let's say I've got another object over there, yeah? If I'm zoomed into this, if I want to zoom out to the full extent of my drawing, without anything selected, I could type in ZEA, short for Zoom Extents All, hit enter, and that zooms out to the full extent of my drawing. So this is particularly useful if you've lost a piece of geometry, if you've moved something out of the way, for instance. It enables you to quickly find it again. And then maybe I want to delete that. So I just select it and hit the delete button. And now if I type in ZEA, you see it's just going to zoom into this because that's the only object I have in my drawing. So that's how I would orbit and navigate around. Hopefully you find that useful. Right, I just want to quickly address a couple of those issues that I said I would mention. So the first one with the 2D curve tools, the first one is going to be this control point curve. In fact, before I talk about that, I'm just going to talk about Polyline. You see that there are line tools and polyline tools. Just for those of you that are new to technical drawing, there is a single line and there is polyline. Single line obviously gives you a single line segment. Polyline will give you a joined up line made of multiple segments. Poly coming from the Greek meaning many. So many line, polyline. So ideally, whenever you're drawing something like a floor plan, ideally you want to be drawing with polylines where possible. It's just good practice to keep your line work joined up where you can. Reason being for this is if you're going to be doing something like laser cutting, for instance, if your line work's joined up, it means that the laser cutter head is going to be following your curves in a logical order, which means you're going to get your line work cut much, much faster. Or if you're trying to CNC machine something, let's say you've sent something off for fabrication, it's going to get cut on a CNC machine. You know, if you've got nice, clean, closed curves like this, and it's all joined up, then you could tell the machine to cut either on the curve, inside the curve, or outside the curve. Whereas if everything is made of individual segments, if I just explode this, if it's made of individual segments, it doesn't know which side is the inside, which side is the outside. So again, try and join things where you can. You can, of course, just select things and type in the command join, and that'll join it all back together. Again, it's a really logical software. If you know what it is that you want to do, just try typing in what it is that you want to do, like join or extrude or revolve, and chances are you will find the tool for it quite quickly. Oh, I've just seen my dreaded question. Can we provide a specific angle while drawing a polyline? No. And this brings me to my most hated part of Rhino. For some reason, there's not an option to define an angle when you're drawing. So for instance, I'm drawing my polyline. I could define this as, I don't know, 1,000 millimeters again, and type in 1,000. There is nothing up here that allows me to set an angle. So it's just saying next point of polyline. I've got my mode set to line. There's no other helpers or anything. There's nothing that I want to modify there. Essentially, there's no option to set an angle like you could in CAD. In CAD, you could hit the tab button and set an angle. In fact, what has that done? No. Have they fixed it? Hang on. I don't think they have. Okay, I'm not quite sure what tab is doing there. I think that's a new function in Rhino 7. I've not come across that. I'm going to need to explore that. But essentially in Rhino, you could, in AutoCAD, you could type in 1,000, hit enter, or hit tab, and you could define an angle. In this one, you can't. But what you could do, just constrain it to a set angle, and then you could just type in rotate and rotate it into place. It's not ideal, but it does do the job. So for instance, I've just rotated that to 45 degrees. And then you could just draw orthographically coming off of that to set your other walls and stuff. A bit of a workaround. I might explore that in a minute, actually, because it does look as though they have added something in. So 1,000, tab. No, I'm not quite sure what it's doing there. I'm not sure why it's set that to white. Ah, you can do it, I think. So I think if you set, if you do a little comma, I think it's setting an angle, though that doesn't look 45 degrees to me. No, it's not doing it. I'm not quite sure how that's working. For now, I'm going to say no, just rotate things into place, but it looks as though they are working on something. Right, that kind of addresses polyline. The next one was control point curve. Now, most people hate control point curve to begin with, I'm going to show you a much nicer way to work with it. So when you're using control point curve, typically it's going to try and do something like this, yeah? You're clicking to place your points, and the curve doesn't fit through the points. So it doesn't feel very logical. It's worth mentioning as well that when you want to finish a curve, you want to hit enter. Don't hit escape like you would in CAD. Hit enter to finish it. Now, the standard control point curve, you see where we've placed the points, and you kind of see what it's doing. It's using these points as anchors. So it's going to loosely fit between those points. Some of you are going to really like that. Some of you are going to hate it. Now, what you're probably looking for is this tool just here, curve interpolate points. And you see that when you click and hold on these, or when you click on the little arrows next to these, you can get to subtools. So I want you to find this one. The icon looks like little points with the curve running through the points rather than next to them. And it should say curve interpolate points. Now what this does is when I click and place my points, the curve now fits through it. So a lot of you are going to find this much more logical to use. This is my preferred way to create these types of curves. I find this so much nicer. So again, give that a try, see how you get on with it. I'm going to give you about 60 seconds. In fact, no, I'm going to give you 2 minutes to play with those two. So the standard control point curve tool, and then I want you to click and hold on it and go to curve interpolate points. On Windows, it's the second option. On Mac, I believe it's the third option, if I remember right. So someone's just asked if I could do that again. So curve, well, the standard control point curve is like this. So you see it places these anchor points where the curve doesn't fit through it. If I click and hold on it and go to curve interpolate points, when I click, the curve will now fit through the points. So again, I just want you to explore playing with that. I'm going to give you 2 minutes, and I'm going to quickly talk about rectangle, and then we shall be moving on to 3D. There you go. I think that's probably long enough. I know it wasn't quite 2 minutes, but it doesn't take too long to make a couple of squiggles. Hopefully you get the idea of what these are doing. Now, I do just want to mention at this stage that because we're essentially creating these objects by defining points, either with measurements or just by clicking, it does retain all of these points. So this is, again, the great thing about using Rhino for curve stuff. So for instance, if I click on my first curve over here, this is my standard control point curve. When I click on it, you see it brings up its control points. And this means that I could click on a control point, and with my Gumball enabled, I can move these points around. So it enables you to very quickly reshape curve geometry. If I do the same thing with this one, you'll see that, oh, hang on, this still looks exactly the same. Well, something's surely got to be wrong, right? If I go back and make my curve interpolate point again, I can see it's definitely fitting through my points, but when I select it, that's not where I left my points. And essentially, this is just the nature of how curves are defined in Rhino. So you're not going to be able to see the points on the curve, unfortunately, but you will still be able to move them around with its control points. It's a little bit frustrating, but hopefully still quite useful to understand. You're not doing anything wrong. It's just the way that curves are defined. How can we measure the curve angles? So there are some measuring tools in this. Let's say I've just got a standard object like this, for instance. If I wanted to measure between these two, I do have the Analyze drop-down just at the top. So if I go to Analyze and go to Angle, I could click start of my first line, end of my first line, start of my second line, end of my second line, and it will tell me the angle of that. So the angle of this is 81.12. Now that's fine if you're working with nice straight rigid geometry. If you're working with something super squiggly like this, then obviously trying to work out an angle of this just isn't really going to work because there's nothing to really define it by. You could set up some kind of basic references. So for instance, I could do a line that represents that. I could do a line over here that represents that. And I could get an approximate angle between the two. That would be fine. But typically you wouldn't want to do it between curves like these. In fact, there's another really useful one. If you wanted to work out the length of a line, a lot of people tend to use it just for single lines like this. So for instance, if I want to work out how long this is, I could go to Analyze, I could go to Length. It tells me the exact length to 0.8 of a millimeter or 0.1 of a millimeter. It doesn't only work on straight lines. So for instance, I could select this curve here, go to Analyze, go to Length, and it will actually tell me the measurement along the length of this, which is really, really nice because otherwise that would be almost impossible to measure, right? There's no way to kind of stretch this out straight to measure it and to put it back again. But this will tell you the measurement along it. So it's really, really nice. Let's say, for instance, you're building a paper model. You know, if I wanted to make a wall out of paper, I could print this off and I could work out the measurement of this along this. Currently, this is 38 meters, so I'm going to need a very big bit of paper. If I scale this down to a more reasonable scale, I can ensure that my piece of paper is long enough to fit along this curve just by going to Analyze, Length. As long as that measurement is the same or shorter than my piece of paper, I'll know that I can fit my piece of paper along it. So again, it's quite useful to be able to work with. I just want to quickly talk about the rectangle tool. Rectangle tool is the only one that's slightly different to the others. So for instance, it says first corner of rectangle. If I could click to place my first corner, it says other corner of rectangle. And not once did it ask for a measurement. So some of you may find that confusing. I'm just going to go back and do it again. I'm going to specify the first corner of my rectangle. But this time what I'm going to do, I'm going to click on where it says 3 point in my command line. So what I'm going to do, now I've clicked on 3 point, it's asking me to define a single length. Maybe I want this to be 2 meters. So I'm going to type in 2000, hit enter to define the measurement. And now I'm going to click to set the angle. So maybe I'm just going to choose a random angle. Now it's defined that first length at this angle. Now it's asking me to define the width. So maybe I want this to be 5 meters. So 5,000, hit enter. And now I can click again to decide which side of that first line I want this to place. So that can be quite confusing when you're first starting with Rhino. But again, the more you get used to it, the easier it becomes. Key thing is just to follow the instructions in that command line. It's always going to tell you what you need to do next. The key thing as well to remember is to always hit enter between commands or between instructions. If I go over that one again, for instance, I'll place my first point. I'll set my 3 point. It's telling me to define the end of this edge. So that's asking for a measurement. So 1,000. I need to hit enter to OK that measurement. It's now not giving me anything, any instruction, but I know I've defined this, so I know I need to set an angle. It's the only thing I can change here. So for instance, I could hold shift to set that straight. It's now asking me for width. So again, I'll type in my measurement, maybe 2000. I need to hit enter to lock that in place. And again, the only thing I can change now is its orientation. So I'm just clicking to place. And now I've got my rectangle with measurements. So again, hopefully you find that useful. I'm aware that we've been going for an hour and a half already, but we've covered all of the boring bit. We've covered all of the interface and all of the 2D tools, which means that next we are finally moving on to 3D. I'm sure you'd be pleased to know. Is it worth me giving you a 5 to 10 minute break for a minute, just so you can stretch your legs? It's not good to sit down for 3 hours solid, especially if you don't have a dedicated chair. In fact, yeah, let's take 5 minutes now and meet again at 11:30. So you got 5 minutes to quickly go pee, make a coffee, whatever you need to do. I'll see you in 5 minutes. Bye. We're going to start again in about 30 seconds. But just to give you all time to come back. Then we're going to move on to some 3D. I think that's probably about 30-ish seconds. Right. So, as I said right in the beginning, the first half of the session is going to be the boring half because we need to go through the interface and the 2D tools and basic use of using Rhino. From now on, we get to do the more interesting stuff, the complex 3D modeling. So, what we're going to do, I'm going to bring this back to having my 4 views. So I'm just going to click up here where it says top. I'm going to go to restore. It's going to roughly zoom in so I can see the same grid in the middle. What we're going to do, we're going to move straight down to the 3D primitives. So we are going to cover extrusions in a minute. I want you just to get a feel for the 3D objects first. So you see down here over on the left, we got box, or you could type in the command box if you just want to make it and hit enter. And again, it's just a case of following the instructions. So this actually works exactly the same way as the rectangle tool. So for instance, I could define a first point. I could click to define an opposite corner, or I could do a 3-point. That would also work. And I could type in my X and Y dimensions. And then once I've finished my rectangle, it will automatically go to my height. And again, I can move my cursor between different viewports. So for instance, I'm in my top view at the minute, which obviously I can't define my height in that view. If I move my cursor down into one of my side views, like front or right, you see I can extrude up and I can extrude down. And same thing in perspective. If I move my cursor to perspective, I can move it up and down there as well. And I'm just going to click to place for now. Now, those of you that are coming from SketchUp, you might prefer just to work directly in a single viewport, just because that's how SketchUp tends to work. And again, it's the same principle. I could go back to my box tool. I could define my rectangle, move my cursor up. Some people prefer to work that way. And there's no right or wrong. It's just whatever works for you. So I want you just to get a feel for that at the moment. And I am aware that by default, your 3D objects are going to look like this. And that's absolutely fine. We're going to look through the visual styles next. So I want you all just to make a quick box. Again, we're not going to type in measurements just yet. I think that's enough time to make a box. For anyone who missed it, click the box tool or type in box and hit enter. Click to place first point, click to place second point, move the cursor upwards, click to place third point. You should have some boxes. So I just want to talk to you about the visual styles. So by default, it will show this in wireframe. Wireframe is the lightest way to view your 3D models. And what I mean by this is if you're running a particularly slow computer for any reason, or if you have lots of stuff open, this is the mode where it's going to be the most optimized, the fastest to preview. So it's going to stop your computer from running slow. Now, the downside to this is we obviously can't see whether these are solid objects. For all I know, these are just curves that have been arranged in 3D. I don't know if this is a filled-in solid object. So what I'm going to do, I'm going to right-click on perspective or click on the drop-down. And I'm going to look at my different visual styles. So the one underneath wireframe, in fact, you'll see we're on wireframe with the little dot at the moment. The one underneath wireframe should be shaded. So I'm going to click on that. This is the second lightest viewing style. So this is the one that I recommend when you're working in 3D, especially when you're working with really complex models. Typically, you're going to want to put this in shaded mode. The reason for this is that we can now see the different faces. We can see our 3D object much more easily, but it's not having to calculate light and shadow, materiality, anything like that. It's just showing our basic faces and volumes. And again, if I wanted to orbit around an object, just for anyone who missed it earlier, I can select an object, type in the command ZSA and hit enter, and it will focus just to that object. Now I can hold my right mouse button, move my mouse around, and orbit around it. And likewise, if I wanted to focus on this one, click it, ZSA, hit enter. Now I'm orbiting around the middle. Or if I select all of the objects and type ZSA, again, it's going to focus to all of them. So again, when you're working in 3D, this is a really, really nice way to navigate. I cannot recommend it enough. So I think making a box is pretty straightforward. Again, for anyone who wanted to add measurements, it's the exact same way you did it with the rectangle. So I could click to specify my first point. I could do the 3-point method. Let me just turn ortho on. So for instance, I could type in 1000. In fact, I'm going to do 10,000 just to make a bigger box. Type in 1000, hit enter, set the angle. Now I need to do my width. So maybe I want to do 5,000, hit enter, set the angle. And then I could choose to extrude that upwards if I wanted to. Oh, there's a good question. So question in the chat, can you edit the measurements after doing the cube or shape? No, it's one of the downsides of this type of modeling. So if you're working in something like Revit or Vectorworks or even SketchUp, you can redefine the measurements of an object. So for instance, let's say I told this cube over here to be 1000 by 1000 by 1000. If I wanted this to be a height of 2000, in another software, I could just select the object, and in properties, I would change the height value. In this software, you can't do that. What you make is what you make, essentially. But luckily, the good thing with Rhino is it's so fast to make these objects that it's actually not too big a deal if you do need to redefine it. So for instance, with this box, instead of using the rectangle tool, if I use the box tool, I could just type in my measurements. And in fact, you don't actually have to click on 3-point. You can just start typing measurements. So if I type in 10,000, hit enter, type in 10,000 again, hit enter, then move my cursor in a direction I want to do this in, type in 10,000. In fact, let's do 5,000. You know, you can define it quite quickly doing it that way. So rather than clicking on a thing, finding a height value, reconfiguring it, etc., it's easier just to quickly rebuild it. Can be annoying though, I do agree. Right, I think that's fine for boxes. Now what I want you to do before we move on to merging these objects together and subtracting them from each other, which is Boolean operations, I want you just to explore the remaining 3D primitives, because this is the last of the easy bit. This is where we're going to start moving on to complex objects. So I want you to click and hold on the box dropdown just over here. And you see we've got cylinders, we've got spheres, we have ellipsoids, pyramids, that torus that I was making earlier, the donut. I want you just to play around with these, follow the instructions in the command line, and get a feel for how they work. So for instance, the cylinder basically works the same as the circle tool. So base of the cylinder, radius of the cylinder. So I'm going to set 1000, hit enter, and then height of the cylinder, maybe 3000. And you're always hitting enter after each command. Or of course, you could just click around and just not define them. So I could just click, click, click. Fast way to make a cylinder. So get a feel for each one of these. You're going to end up with a range of objects. I'm going to give you about an extra 60 seconds. Actually, no, I'm going to give you 2 minutes to play with these, just because they might take a little bit of getting used to. I think once you can make objects like these, you can make just about anything. So again, I'm going to give you 2 more minutes. Then we're going to play with some more interesting stuff. There we go. I think that's close to 2 minutes. Just going to pause there just to see if there's any questions. Again, you can either type them in the chat or you can unmute and ask some questions. I'm sure there must be at this stage.
Hi.
Hi.
And the pipe shape is not working for me. Is that, are we trying that shape or not?
Yeah, we can try the pipe shape. So the pipe shape, assuming it's this one here, the tube. Is it this one?
The row below it, so the first one.
The row below, this one here. So pipe flat caps. Yeah, that's a good one. So at the moment, there's nothing there to use as like a reference. What this is essentially asking is it's asking for a rail to be selected. And a rail is essentially just a type of curve. So if I use my control point curve, just to make some kind of squiggles, let's say something like this. Maybe I want to make like a railing or something like that, or a banister. If I go to my pipe tool, pipe flat caps, I can select my rail. I can now define a radius. Oh, so something like that. I can do the same thing on the other end. I can hit enter and it will create a pipe along it, which is really cool. Now, the cool thing about this is you can do this with multiple radii. So if I do it again, if I go back to pipe, I can tell this to have a really thin one, really small circle there. I can tell it to have a bit of a bigger circle over here. I can even click along it to define different radiuses. Radiuses, radii, one of those. And then when I'm happy, I can hit enter. And you see what's happened here? It actually didn't compute it. And the reason it didn't compute it is because my curve was too tight and because I had a really wide radius set past that curve. So if it's going to result in like self-intersecting geometry, if it can't fit that size there, it won't let you create it. So I'm just going to quickly do that again, but this time with smaller ones where the bends are. So let's go for smallish ones there. Anywhere where there's a small bend, I'm going to have a small curve, something like this. I could go for much bigger ones over here, something like that. In fact, it still didn't like it. It is a really temperamental tool. In fact, let's just go from big to small. There we go. Let's just go to a really small one now. There we go. I think I was just adding in too many control points. So I had a big radius there, tiny radius in the middle, and you kind of see what it's done. I don't know why I would want to model something like this, but it's nice to know that we can.
Yeah.
The key, sorry, say that again.
That's it, thank you.
Okay. Yeah, the key thing, whenever you're using pipe, is just to make sure that whatever thickness you're setting when you get an object that doubles back on itself, you just need to make sure that it's not going to be self-intersecting. It's not going to overlap itself. Give it a try, see how far you get with it. Do we have any more questions with the 3D tools? Because again, these are just the primitives. These are the basic shapes for now. I'm just going to give an extra few seconds just in case a question comes through in the chat. But at the moment, doesn't look like there's any questions. No. Right, in that case, we're ready to start moving on. So as you can see, we've got some really basic objects. We've got our boxes, we've got our cylinders, spheres, torus, etc., and tubes. These are fine if this is what you're trying to create. You know, if you're trying to just work with basic primitive objects, you know, we could work with these, especially if we're trying to work with like a tube or something like that. You know, it's very easy to make pipe work. But what if we want to make something a bit more complex, for instance, walls? Well, that's very easy to do as well. So what I'm going to do, I'm just going to quickly draw a rough floor plan. So I'm going to use my Polyline tool. I'm not going to do this to any particular dimensions, but just in my top view, I'm just going to roughly outline a building. In fact, I'm going to turn my smart track on just so I can bring this up nice and clean. So I'm sure most of you have drawn the outline of a basic floor plan before. You can quickly do this now, or you can just use a rectangle. That would be equally fine for this exercise. But if I wanted to extrude this, if I wanted to make this become like a wall around the edge of this, then typically I'm going to want to offset it. And this is where typically you would actually want to do it to scale. In fact, let me just measure some of this. If I go to analyze and length, in fact, I'm not going to go length, I'm going to go distance. I'm going to go analyze and distance, just click between 2 points, just to give you an idea of scale. So I've clicked between there and there. On my quick floor plan, I've drawn up this line here represents 12 meters, 12,451 millimeters. So whatever you've drawn, just quickly double check a measurement by going to analyze and distance, measure between 2 points, and it will tell you that measurement in your command line, or over on the left if you're on a Mac. So I know that this line represents 12 meters. Now, if I wanted to create a wall for this, the first thing I'm going to want to do is make sure everything's joined up. So I've selected my curves. I can see in my properties that it says closed curve. So there's no open objects. If it was made of individual segments, I might want to click my my drawing. So select everything by clicking and dragging, type in join, and hopefully that should close your object. It should now say closed curve. If I want to create a wall thickness, I probably want to offset this. So again, you do have various tools over here. You won't always find what you want, but what you will come to realize is you've actually been using the same tools in these drop downs. So for instance, the curve tools, you've actually been using all of these already. So curve, arc, ellipse, rectangle, polyline, etc. You're already using them. They're the same commands as these on the left. The same thing with the solid drop down. You know, you've been using all of these 3D primitives already. You're actually using a lot of these tools. Now, if the way to use these drop downs is it depends what you want to do with it. So for instance, I'm currently working with curves. I can see when I select my object, it's a curve. I want to continue making another curve from this shape. So that means I need to use my curve drop down. So if I go to curve, I can go down and I can see there's one called offset. I could choose to offset my curve. Or of course, if I want to make it easier, I could just type in the command offset and that would do the same thing. I prefer working with commands. In my command line, I can choose to set an offset distance. So maybe I want a wall thickness of 300. So I'll type in 300, hit enter. And you'll see now I can click to place either outside my plan or inside my plan to choose which side to offset. I'm going to offset outwards. I've now got a nice, clean, consistent line thickness all the way around. So it's the same way you would do it in CAD, more or less. I'm just going to quickly repeat that because I know someone's going to ask any second. I want to select my curves first. And if you haven't drawn a floor plan, again, you can just draw a rectangle. It will work this exact same way. I'm just going to type in offset. I'm going to come to my command line and go to where it says distance and click on it. Type in a measurement. So I'm going to choose 300, hit enter. And now that my distance is set, I can just choose to click either outside or inside my object to choose where to offset it. And one cool thing about Rhino is if I wanted to use that exact same tool again, and if I want to use the same measurements and everything, like the 300 offset, all I need to do is hit the enter key to load the last used tool. So you see straight away it's gone to my offset. I can just click straight outside. I don't need to retype anything in. Just hit enter to load the last tool. So once you get used to it, it's a very, very fast way to work. So again, going to give you all 60 seconds. I want you to quickly make a shape. Could be a floor plan, could just be a rectangle. I want you to offset. So you should end up with something like this as a curve. Once you've done that, we're going to extrude it together. Again, just about 60 seconds or so. There we go. I think that's more than enough time to quickly draw some shapes. So what I'm going to do now, I'm going to come back to my 4 views and I'm going to go to my perspective view. So I like to work in full screen when I'm doing extrusions. So again, if I wanted to focus my view, I could select my object and type ZSA, hit enter, just so I can orbit around my plan. Now, there's a couple of different ways that we can extrude, and there's different reasons you would use these different tools. And this is the first time I would recommend that you don't use the keyboard shortcuts. So for instance, I could select an object, I could type in extrude. In fact, let me just turn something off. I could type in extrude, but there's a bit of a problem with this. I don't know if I'm going to extrude this as a surface or extrude it as a solid. I just want to quickly show you the difference between those. I'll just copy and paste this object to the side for a minute. If I were to select these 2 curves on the left, and if I went to my surface drop down, because I now want to make a surface, I could go to surface, extrude curve, and straight. I could click to place it. I'd say it looks okay, but the problem I have at the moment is that these walls are hollow. And that's not ideal, especially for anything like 3D printing, for instance. If you wanted to 3D print a model, or even if you just wanted to visualize it nicely, having open geometry like this is generally quite bad. So that's what happens if I use surface. So remember, surfaces don't have a thickness. It will only create open planes. If I select the exact same 2 curves again, remember I just copied and pasted these. If I go to my solid drop down and choose the same tool, extrude curve and straight, when I extrude it up this time, you see it's nice solid walls. So that's essentially the differences between surface and solid. Surface will give you individual surface planes like these that are open. Solid will make a closed boundary. Now that was obviously with 2 curves selected. If I had just 1 curve selected, I go to surface and extrude. Again, it's not going to make a closed boundary. I'll do the same curve again over here, but go to solid and extrude. It'll make a closed boundary. So hopefully that gives you an idea of what's going on with these. So back over here on my plan, if I wanted to make nice solid walls, I know that I need to select both of these curves. I need to double check over here in my properties that they're both closed curves. If they're open curves, it's not going to work. And if I go to solid, extrude curve, or planar curve and straight, you see I can extrude these up. And I can even type in a measurement. You know, if I wanted this to be 5 meters high, hit enter, and it's now extruded out up to 5 meters. So again, it can be quite a fast way to go about things. Kind of similar to push-pull, but instead of selecting a surface, you're selecting curves and typing in a measurement. So it's a similar principle. Does anyone have any questions on that before we move forward? Nope, no questions. I think it's quite straightforward. Okay, the next thing we're going to look at is Boolean operations. So we know how to extrude something, but what if we want to cut out a window or a door or something like that? Well, that's really, really easy to do. So for instance, I'm just going to make a couple of shapes. In fact, I recommend everyone makes the same shape as me. I want you to make a box. And I want you to make a sphere that has the center on the corner of the box. So once you've made your box, I'm going to go to my sphere tool, which you can see in the 3D primitives. I'm going to make sure I've got my endpoint snap so I can click on the end of this box or the corner. Now when I click and drag out, you'll see I can define my sphere. In fact, let me just select these and do ZSA just to center them a little bit. So again, I'm going to give you 30 seconds to make make a sphere and a box that overlap or intersect. I'm going to show you how you can use Boolean operations. In fact, just while we're waiting for people to make the box and the sphere, who can tell me what a Boolean operation is? Has anyone ever heard that term before? Nope. Okay, not to worry. So a Boolean just basically means it's going to mathematically compute whether you're adding something together or subtracting it, and so on and so forth. So it's a good way to subtract from a volume. And I recommend that you're working with two closed objects when you do this. So for instance, if I select my sphere, I can see that's a closed surface. If I select my box, I can see that's a closed extrusion. So even though they're different types of geometry, as long as they're both closed, you'll always be able to use Booleans. Now, because they're both closed objects, that means I'm going to be using the solid dropdown. If they were open like that other surface we saw before, I would be using the surface dropdown. But because they're solids, we're going to be using the solid dropdown. So if I go down to solid and all the way down to this section down here, where you've got union, difference, intersection, etc., we can start merging these objects together. Now, just to show you what's happening with the geometry here, I'm going to change my visual style to ghosted. So that means that I can see through my objects. I can still see them in 3D, but I can see through the objects. And you see at the moment, I can see my box protruding into the sphere, and I can see the sphere protruding into the box. Then what I'm going to do, I'm going to come back to solid and come down to union. And I'm just going to follow the instructions. So select the surfaces or poly surfaces to union. So I'm going to select my two objects, hit enter, and you see what it's done. It's not moved the objects or anything, but essentially it's trimmed the objects against each other and then joined them together. So it's trimmed that box against the sphere at that edge around there. It's trimmed the sphere against the box, so it's no longer intersecting there. And it's just welded them along that edge. If I come back to my shaded view, you'll see again, they look exactly the same as they did before, but now they're a single object. So that can be particularly useful. Just going to bring this back to ghosted mode. Now, if I wanted to undo this, you could of course go to edit and undo, or you can do Control Z, same as you would in any other software. I want you to just go back to when they're two separate objects. So I can select my sphere, I can select my box. So go back to two separate objects. Now this time I'm going to be looking at difference. So I'm going to go to solid and difference. This time we don't want to select them both at the same time. So look at the instructions. It says select the surfaces or poly surfaces to subtract from. So what do we want to subtract from? I think I want to subtract the sphere from the box. So I'm going to select the box, press enter to continue. Now it's asking to select the object to subtract. So I'm going to select my sphere, press enter. And you see what it's done. It's subtracted the sphere from the box, which is pretty cool. Now, again, I'm just going to fly through these. I've just undone it again. I could go to solid and I could go to intersection. It says select the first set of objects, press enter when done. Select the second set of objects, press enter when done. And now it shows me just the intersection of those. So it's removed everything else other than where they overlap. So again, these are really powerful tools. These are really, really useful for various purposes. But I would say if ever you get too stuck, if you can't figure out which one you want to use, you have the option to do Boolean to objects. And I really like this one. So if I do Boolean to objects, it says select the two objects to Boolean. I don't need to hit enter at any point in this stage. Instead, I can just keep on clicking to iterate through the different potential Booleans. So for instance, subtracting the box from the sphere. I've run out of Booleans to do. Let me do those two again. So 1, 2. So I've got my intersection, subtract the box from the sphere, subtract the sphere from the box. Not sure what that one's doing. I think that's a Boolean split, where it's split them, but you get to select the individual objects. And then this one is the union. And then once you're happy, just hit enter. So again, I am going to give you a couple of minutes to play with that one. That is a very, very important principle of 3D modeling. I'm going to quickly make a box and just show you what you can do with this. I'm going to make a box with equal sides, so 1000 by 1000 by 1000. You don't have to do what I'm doing. I'm going to enable my end and my midpoints. And I'm just going to copy this object around. So I'm going to select my object and type copy. Select a point to move from, click a point to move to. So copying and pasting is just the easiest thing in this. So I'm just going to place a bunch of these spheres on the corners. I messed that last one up annoyingly. Let's do that again. So copy, point to copy from, point to copy to. So now I've got something like this. I can now use my subtract tools. So I can go to solid and difference. Thing to subtract from would be my box. Now I can just go around and start subtracting some of these spheres. So again, very fast way to make some quite complex geometry. So again, going to give you a couple of minutes just to play with those Booleans, get a feel for them, and then we'll move on to the next step. We're going to start moving on to more organic forms in a second as well. I'm sure you'd be pleased to know. Just want to remind you as well that, as always, if you have any questions about any of these steps, just shout out or just type in the chat. Especially when it comes to Booleans. Booleans are quite tricky if you're quite new to it. I think that's probably enough time to play with them, to be honest. They're quite straightforward. You guys are switched on. Oh, there is a question. Can you go back into the command box to a certain point where you were working? Oh, you mean like history, like object history? Is that what you mean?
Hi. Yeah, like an undo. So basically you go back to see, what you were doing and then go back to a certain point where you were working and you want to start from there.
That's a good question. Yes, you can. So you do have the option to record history. To be honest, I've never bothered using record history. But essentially what it will let you do, once you set it to record, it's going to record all of your commands that you do from that point. So for instance, I could extrude some surfaces. I could start clicking some faces, pushing and pulling these, which is kind of cool. That's really starting to look quite complex. And I believe, in fact, where is history? I'll just type in history. Ah, it's not recording. Okay, I thought I told that to record. If you tell that to record history, then I believe you can then start extruding and pushing and pulling these things. And when you type in history again, I think you can choose what step to go back to. To be honest, I usually find that a little bit on the tricky side to use. So I would usually just use the undo tool, to be honest. You can go back any number of steps that you like with Rhino. I don't believe there's a cap on how many undos you can do. I prefer just going back and forth with undo and redo. Probably not the proper way to do it, but it is the way I've always done it.
Thank you.
I do find as well, by the way, the reason I don't use record history is just the amount of extra RAM that it takes up. So typically I've always used machines with low amounts of RAM, like a laptop with 16 gigabytes of RAM. Using record history does tend to use a lot of extra, which is why I've always used the undo functions instead. Again, if you've got a more powerful laptop or more powerful machine at home, maybe start using record. But it's up to you. Right, I think we are at last ready to start moving on to some more complex forms. You'll be pleased to know. Final thing I did just want to mention, obviously you just saw me extrude these faces. When I went to solid previously, you saw I was using extrude curve because we were working with curve geometry. That's what we were extruding. If I wanted to extrude these faces, I would choose extrude surface because these are surface objects. So if I want to go and make it into a solid, I use a solid drop down, extrude surface and straight. Select the surfaces to extrude, hit enter. And I can either just push and pull these, or I could type in a measurement to extrude it by. Another thing to mention with these as well, just quickly, is when we're extruding, currently I've been extruding these objects straight, but you can choose to extrude them along curves or to a point or even tapered. So for instance, if I choose tapered, I can tell these to extrude to a specific angle, like to a specific draft angle. And I could set that draft angle up here in my command line. So again, that can be a particularly useful thing. So for instance, this one is extruding outwards. I would want to set the draft angle to a minus value in this direction. Whereas if I do it on the other side, it's going to do it downwards. I want to do it this way. I can either flip the angle, or I could just type in a minus value. So again, good way to create some complex geometry. Let's flip that again. So I'm not quite sure what it is that I'm trying to make here. It looks kind of funky. Flip that angle. So one thing that I haven't mentioned yet is one of the visual styles. The one that you're probably going to want to use quite often because it looks the nicest is rendered. So rendered view does look quite nice. It's a good way to preview our objects. And the good thing about the rendered preview in our dropdown is that this will show actual lighting and shadow and materiality. So remember in the beginning when I showed that materials tab, I showed you where you can import things. You can obviously make custom materials and stuff as well if you want to use your own textures. But if I were to apply materials, this is where I'd be able to see them. I wouldn't be able to see them in my shaded view because this is just a quick 3D preview. So I just wanted to quickly mention that. Now I'm going to show you how to do surface modeling. And this is probably the thing that you all came here for. This is how you can make complex forms. And I'm talking about proper organic forms. So this is where it starts getting really fun. So what I want you to do, we're going to make just a single surface that's a floor plane. And the command for that is plane. So P-L-A-N-E. And I'm just going to click and drag to make a rectangle. So again, I'm not typing in the command rectangle. I'm typing in the command plane because I want to make a surface plane. Alternatively, you could just go to surface and you could go to plane if you wanted to. We're going to make a surface plane. Now, this is where it gets fun. So I'm going to start turning on the control points for this, and we're going to start manipulating it. So I want you to select your surface plane that you've just made. Make sure you're in shaded view for this, by the way. I want you to select your surface plane, and I want you to type in the command points on. So I'm going to leave that up on the screen. Points on. Hit enter. So what this does, you see it's turned on the 4 control points. So currently this is a really simple surface, only has 4 control points. So I saw someone's just rejoined the meeting. The control you want to type in for this, or the command even, is points on. So now that we've turned the control points on for the surface, I'm going to select one of my control points. I've made sure that my gumball is on. So again, if you're on Windows, Gumball is down the bottom. If you're on Mac, Gumball is going to be at the top. I'm just going to drag the blue arrow to move this point up in 3D. It's moving up on the Z-axis. I'm going to do the same thing to an opposing point. Instant pavilion. Beautiful. And again, you'll see if I view this in my other views, from top view, it's still nice and square. From my side views, it looks something kind of like this. ZSA. So if I orbit around, you see what I've done. Now, this is kind of cool. It's not bad, but currently I'm very, very limited in what I can do with this. And the reason being is that I've only got these 2 control points in each direction. So 2 on the X-axis, 2 on the Y-axis. And in fact, using the terms X and Y-axis in this instance is actually incorrect. So I'm just going to talk to you about coordinates for a second. If you imagine that most 3D software work in axes, yeah? So we've got our X-axis, which is this red one. And I can see this by this little icon, this little totem in the bottom left. My X-axis is the red one. My green axis is the Y-axis. And my Z-axis is usually blue. And this would be my height, my extrusion axis. Now, surfaces or 3D objects have their own coordinate system. They could be moved around on the X, Y, and Z axis in 3D space, but the object itself has its own coordinates. And a good way to think about this is if you think of a globe. Yeah, something like this. Think of the grid that's on a globe. Essentially, this is what we call U and V directions. So it's its own coordinates. V usually stands for vertical. I can't remember what the U stands for. I can never remember what the U stands for. I believe V is vertical, but typically all it's doing is it's unrolling an object, just like you would a world map, and it's assigning a grid across it. And that's essentially what's happening with this. Currently, we've got 2 points in our U direction, 2 points in our V direction. So how do we add more points? How do we increase the resolution of this object? I'm going to select my object, type in the command rebuild. So not rebuild mesh, just rebuild. Hit enter. And we get some controllers. Now the way this works, we've got the point count. It tells us our U and V point counts. And whatever's in the bracket is its current settings. So currently it has a U direction of 2 and a V direction of 2. Now I could increase these. I could increase one of these directions to be maybe 6. Maybe the other direction is going to be 4. I'm just guessing numbers. I'm not being specific. I'm just going to click OK. I'm not going to worry about degree just yet. I'm going to show you what it does in a minute. So the first thing you'll notice is the number of segments on this object has changed. And when I select it and type points on and hit enter, you see I've now got a lot more control points to play around with. Now, this is great because that means I can now start selecting multiple control points. I recommend you hold shift if you're selecting multiple objects or multiple points. I can select multiple control points, move these up on the Z-axis, and suddenly we're creating some more complex things. So maybe something like that. I'm sure you can imagine why this is so useful. You know, if we're doing some kind of landscape modeling, like terrain modeling, anything like that, this is an extremely fast way to basically modify your landscapes. So for instance, you know, if I wanted to work on a specific area, I could just select that area, rebuild it to add in more resolution, turn on the control points, and I can move those points up and down on the Z-axis to reshape it. So it's a nice way to work. So I'm just going to quickly cover all of that again, just ninja fast. So again, I just made a single plane and drag that out. Type in rebuild. Adjust the number of control points that you want. So maybe I want an even number this time, so 4 and 4. Click OK. And then to manipulate it, I'm just typing in points on, if I can spell points on. And now I can move its control points around. Try to anyway. So something like that. It's a really nice way to create organic forms. Does anyone have any questions on that? Okay, doesn't look like there's any questions, so I'm going to move straight on to the next bit. So I'm sure some of you might be thinking by now, well, okay, this looks kind of useful. What happens if I were to select this object and try to rebuild it again? Well, let's give it a try. If I type in rebuild on this object I've already modified, you know, I could lower the number of control points if I wanted to. So remember, this one was the one where we set the U points to 6. If I click OK, you see it's made a more optimized form of that shape I created before, because it's using less control points to define it. Remember what I was saying in the beginning about NURBS? You know, it's just a series of curves that is fitting a surface through. Each time you're increasing or decreasing using the rebuild command, these U and V points, you're adding in extra curves or subtracting curves. So for instance, if I set this to 10 and 10, for instance, you see what it's doing in the preview. It's adding in more curves that define this shape. Now I actually don't want to do that. I'm going to set this to 6 and 6. And this time what I want to do I'm going to be playing around with the degree. So my one is by default set to 2 degrees. If I set this down to 1 for both of these and click OK, look what it's done now. It's now made a really faceted object. So the degree is in relation to the tangency of each of these faces, each of these curves. So there's, now that it's set to 1 degree, everything is going to be super, super faceted. The cool thing about this is you can mix them. So for instance, I could set my U direction to have a nice curvature of 3. And I could set my U direction to have a curvature of 1. And that means that on this axis, in this direction, it's nice and curvy. In this axis, it's really rigid and kind of angular. So again, some really interesting forms that you can create. Now I'm going to stick this to 2 and 2, just because that is the kind of default. That is what I would recommend you work with if you're working with organic forms. Now I'm sure you're thinking by now, well, this is kind of cool. What the hell can I do with this? Well, firstly, if we were going to turn this into like a terrain or something like that, firstly, this is a very extreme terrain, but I'm going to go with it. I'd probably want to give this some kind of thickness. And there are 2 ways that we can give thickness to objects like this. One is by offsetting it in 3D, and the other one is by extruding it, just like we did before. So I'm going to select my surface. And because I want to turn this into a solid object, I'm going to use my solid dropdown. And I'm going to come down to where it says offset. So first thing you'll notice before we type in any measurements or anything like that, first thing you should notice is that there's a bunch of arrows showing you the direction that it's going to be offsetting in relation to the surface. So this one's currently going to offset outwards or upwards. There is a button up in the command line that says flip all. So I could flip the direction of my offset. But I think I'm happy for this to offset upwards for now. Now I didn't measure this. I didn't draw this to any particular scale. So I don't know how thick I want this to be. But I'm going to take a guess and say 300. So I've clicked on distance, typed in 300, hit enter. And that's now set my distance to 300. The last thing I'd want to do is decide whether I just want to offset the surface and have them as 2 separate surfaces, or to decide if I want to make this as a solid volume. For instance, if I wanted to 3D print it. If I wanted to 3D print it or have it as a solid, I'll just make sure that solid equals yes in the command line. So once I'm happy with this, I hit enter. And now I've got a nice solid roof, which is pretty cool. Now this is a really useful one if you need a consistent thickness all the way along. This isn't going to be useful if I wanted to make like a terrain with a base, for instance. If I wanted to make a terrain with a base, I'd want to extrude it down, give it a nice flat bottom to it, and then it's like a nice hill on top of a box. But offsetting it will give you a consistent wall thickness. So imagine, for instance, if you wanted to create a curtain wall, it'd be the same principle. You could create a curve, extrude it up as a surface, offset it to create a thickness. Fast way to work. In fact, let me just quickly do something like that. Let's say, for instance, I'm using my curve here. In fact, that's not a very nice curve. Let's make this a bit more interesting. So again, you don't need to follow along this bit, but it might be nice to just show you what it's going to do. Let's say I have a curve something like this. I'm going to extrude this up as a single surface, something like that. So this could become my wall, for instance. I could now select this surface, and of course I can rebuild it to add in more control points. I should have turned history off. There we go. And now I can type in points on to manipulate my wall. So maybe I want some elements in my wall to push and pull out, something like this. So it's quite organic modeling. And then of course the cool thing with this is I can now offset it. So I can go to solid, I can go to offset, choose whether I want to offset forwards or backwards. I'm going to offset backwards this time. Type in the measurement, make sure it's solid, hit enter, and now you've got your wall object. So again, it is a nice way to go about modeling. Now I'm actually going to undo a bunch of steps just to get back to that original surface that we had over here, just because I want to show you the other way to give this some volume. So I said before that we could extrude this or we could offset. So this time I'm going to offset it. Again, I want to turn it into a solid, so I'm going to use the solid dropdown. And because it's currently a surface object, I want to extrude a surface. I couldn't choose extrude curve because it's not a curve. So extrude surface and straight. Select my surface, hit enter. And I could just extrude this down. And you see this time I've got a nice straight extrusion. And I could now make like a model from this, for instance. Now, one thing I don't like about this is because I've extruded this down, the bottom is going to be exactly the same shape as what we have on the top. It's going to extrude every point down by a set value. I would probably want to give this a nice flat base. So what I would do, I would just put a box over it. So do a box over there. Extrude it past the object. Maybe move it down a little bit. So essentially it looks something kind of like this. Two overlapping objects. I'm sure you can guess what I'm going to do. I'm going to go to solid and difference. Object to subtract from is my nice organic form. Hit enter. Object to subtract is this box. Hit enter. And now, as you see, we've got a nice clean object. So I can now send this for 3D printing, CNC, whatever it is that I want to do with it, which is pretty cool. Does anyone have any questions on that? Again, feel free to shout out if you do have any questions. I would have thought there would be by now. Okay, no questions. Right, in that case, I'm going to show you another cool thing that you can do with 3D. And this next one is called the contour tool. So let's say, for instance, I've got a site model, and maybe I wanted to make a laser cut contour model. For those of you that don't know what I mean when I say contour model, I'm talking about these ones. So either using laser cutting or plotter cutting, whatever method you're using, essentially it's just going to take contours from a 3D model at a set distance between each one. So let's say, for instance, I've got my model. In fact, I'm actually going to take a measurement from this. So I'm just using analyze and distance. So currently this is 14 meters across. So that's a bit big. So I'm going to scale this down. If I want to scale something, just type in scale. I'm going to scale it down to 0.1. Let's get rid of that. So let's say, for instance, you've made a 3D model, you've made it to scale with the correct measurements, you've scaled it down to the scale that you want to physically make it at. And currently my model is 1.4 meters. Still quite a big model, but still fairly reasonable. Well, if I didn't want to CNC machine this, and if it was still too big to 3D print, maybe I want to make one of those laser cut contour models. In which case I can do that very, very easily in Rhino. So what I can do with this, I'll select my object. I'll type in the word contour. I'm going to select a direction. So again, I'm just following the instructions. So it's asking for the base point, the point to start from. So I'm going to start at the bottom. It's asking me to set the direction. So I'm going to click from bottom to top. Now it's asking me to specify a distance between contours. So I'm going to type in maybe 50 for now. When I hit enter, you see it's given me all of this nice curve geometry, which is really cool. Just going to drag these out for a minute. I could do the same thing again. So I'm going to use contour, select from bottom to top. Maybe this time I want them to be every 10 millimeters apart. And again, you see it's generated all of these contours. Now, the reason I'm showing you this is because firstly, we could take each of these contours and laser cut them because they're now just curve geometry. And because they're closed curve geometry, you can just arrange those on a sheet on a laser cutter, laser cut them, stack them up, you've got yourself a site model. But the cool thing about this is because they're all closed geometry, we can now quickly preview this in the software. So I'm going to show you with this one. We've got all of these curves. I'm going to go to solid. I'm going to go to extrude curve because they're curve objects this time. I'm going to go to straight. And if I can remember the distance that I extracted these contours, I could type it in. I think I did this first one at 50. So I'm going to extrude these by 50. Hit enter. And now it's going to show me a contour representation of my model. I can do the same thing with this one, of course. This one I did a contour of 10. So I'm going to extrude this up by 10. And now I've got all of these. And in fact, if I stick this on rendered mode, it should look quite nice. So again, we're now getting into some seriously complex geometry very, very quickly. And you can use this same principle for creating structures as well. So for instance, let's say if I just explode this for a minute. Explode tool's really useful, by the way, to separate surfaces out. Let me just copy this along. I don't think I need to explain how copy and paste works. I think that's quite straightforward by now. If I wanted to do contours of this, I could maybe view this in my top view. Type in contour. I could select from left to right, set a distance. So maybe I want this to do every 20. That gives me all of my curves, yeah? In fact, let me put those on another layer. I'm going to call this layer number 3, just for a minute. Just so I can turn those off, get them out of the way. I'm now going to do contours in my other direction. So I'm going to do it from this way down to this way. I'm going to do the distance between contours the same as I did on my X direction. Something like that. Let's move those to another layer. So essentially what you end up with is this nice kind of grid. So something kind of like this that goes across the object, yeah? Now, what we can do, because I moved these straight away onto another layer, I can right-click the layer and choose Select Objects. So it will select only those curves. And now I can extrude these. So for instance, I could extrude these down. Or I could choose to extrude them along. I did them every 10 apart, so maybe I'm going to extrude them by 2 or 3. In fact, 2 looks a bit too thin. 4 seems to look quite nice. So I'm going to extrude that as a surface by 4. Something like that. In fact, you know what? You can even delete the original object now, or you can move it to another layer that you don't want to use, that massive one, just so we can see what we're doing with this. Let's make this full screen now. So I've still got the curves, but I've now got a bunch of surfaces in there. Purely just by using contour and extrude. That's all I've done. I can turn those curves off as well. So now all I've got is the surfaces. If I wanted to extrude these down to give them a thickness, again, just going to solid. I want to extrude the surfaces and straight. Now, occasionally, it doesn't let you do all of them in one go, which is really frustrating when it does it. But it just means that we need to go back and basically just tweak some of our surfaces. It's not the end of the world. Well, I can just give these a thickness like, I don't know, maybe 10. Yeah. Now we can get all of these little struts extruding to 10. Now, I don't know why it didn't want to extrude that one. Why did you not want to extrude? It just does it sometimes. Rhino does work 99% of the time, but occasionally you will get random issues with things. I'm not seeing any issues with the geometry. That should be extruding. If it doesn't like it for any reason, it's just a case of undoing it, go back to the previous step, and just re-offset your stuff. So if I just go back to this stage, for instance, I want to go to surface and extrude the curve. In fact, I could show you a different thing. Instead of extruding along on our X and Y axis that way, I can extrude up and down if I wanted to. So if I go to surface, oh, we're already extruding. If I go to my direction, I can set my direction from top to bottom, for instance. And now I can tell those curves to extrude downwards. So again, that can also be a really useful one to know about. I'm going to extrude this by a distance of 10. Same as before, I'm going to turn off my curves. I've still got my surfaces just like this. Hopefully this time when I go to solid and extrude surface, it's going to do all of them. It might split up into sections. That's absolutely fine. Yeah, it looks like it's working this time. It's just being temperamental before. Let's do a distance of 5. So again, it's just finding the direction that you want to extrude in. If I put this into rendered mode, you see we've now got a bunch of curves going along quite nicely. And again, you can do the same thing in the opposite direction as well with the remaining ones to create like an interlocking structure. So the resulting geometry here, I'm just going to move to layer number 5, just so I can hide it for a minute. Bring back the curves in the opposite direction this time. Hang on. Yep, that way. And I would just do the same thing again, essentially. So I'm going to select all of these. I'm going to go a bit faster through it this time. So I'm going to go surface. I'm going to choose where to offset. So I'm going to choose a height. My height value, I think, was 10 before, so I'm going to do the same thing again. So I should be left with a bunch of surfaces. And then again, I could just offset these. I could go to solid and extrude, or I could go to solid and offset. And I could just extrude those by setting the direction wherever I want to along. I'd recommend that if you have a mixture of kind of open and closed curves. So for instance, these ones at the front don't go all the way along. Do these ones separately to the ones that do go along. You should have a bit of an easier time of it. But yeah, that's a very quick way to make some complex structures, essentially. What else could we do? We've still got 20 minutes left of the session. So any questions at this stage? I'm kind of just trying to chuck in as many things for the recording as I can so people can play with toys. No questions?
Sorry, I think it's better if I explain it through the mic.
Yeah, that's fine.
So at the moment, we're working through Grasshopper as well, which is very confusing in terms of how the families work. So is it possible to go through that, or is that like a long process that needs another day?
Well, you mentioned families. Did you say you're using Grasshopper or Revit? Sorry.
Grasshopper.
Grasshopper. We are going to be running an intro to Grasshopper session. I don't think it's next week. I think it's the week after.
Right.
If you're able to hold on until then, I would say you'll be absolutely fine. If not, take a look at our ADD YouTube channel. I believe we've still got a ton of the intro to Grasshopper stuff from last year on there.
Okay.
I believe we covered everything on there, all of the essentials that you'd be expected to do in class. So I'd say just take a look at that if you need to jump on. Alternatively, book an ADD tutorial with one of us. We're always happy to help.
Great. How do I book that? Sorry.
Yeah, sure. So the ADD tutorials, you can just do them straight through Moodle. Let's move this out of the way. There we go. So just log into Moodle. Need to verify me thing. Hang on. I hate this two-factor authentication stuff. Yeah, if you go to the Advanced Digital Design area on the main All School Moodle page, go to ADD, scroll down past the workshops, and you will find the ADD Daily Drop-In Clinic. And in here, you can book a slot. I'm not going to show those because it shows everyone's names, but you can just book a slot through there with a member of staff.
Okay. Sure.
Cool. Right. Let me just think if there's any essentials we haven't covered. One of the main essentials we haven't covered is lofting. Lofting is a fantastic way to make complex forms. So I'm just going to quickly delete everything I have here. Don't need those anymore. And instead, what I'm going to do, I'm just going to make a few circles, just 3 circles. And I'll show you what we can do with it. So I'm going to make circle number 1. I'm going to turn on my center snap for this, just because it's going to make it easier. Oh, wrong one. So just a few circles that overlap each other. Something like this. And then all I'm going to do, I'm just going to move some of these circles up just so they're on different planes. So let's say something like this. So let me just zoom selected all. So one thing you can do is what we call lofting. For those of you that haven't heard of lofting before, essentially it just means that we're going to connect curves with a surface. So we're using these curves as guides. Now, the rule of thumb for lofting is you can either use only open curves or only closed curves. You can't mix the two together in a loft. So I'll show you what I mean by that in a sec. But essentially, if I just go to loft, type in the command for loft, select the curves in order, so top, middle, bottom, hit enter. It will show you how it's planning to connect these together. So it's going to say connect this one to this one, this one to this one. It's connecting them kind of in alignment, and the arrows are showing the direction that it's going to connect them in. So this all looks correct to me. I'm going to hit enter. It's giving us a bit of a preview. So currently this looks pretty cool. I'm pretty happy with this already. It's a nice complex form. If I click on the style dropdown in my loft options, you see I actually get further options on how these connect. So for instance, if I choose loose, it's going to loosely fit these curves. So it's a bit more like a tensile structure in that aspect. If I choose tight, it's going to very tightly fit. So it's going to fit normal through that curve. If I choose straight sections, it's going to create a faceted version. So again, you get quite a lot of flexibility over how this works. And if you're creating a relatively complex loft, something with loads of control points in the curves, you could always just choose to rebuild with X amount of control points. So maybe I want to rebuild this with specifically 12 subdivisions. And you see it will equally subdivide this into 12. So it's just setting U and V coordinates essentially. So I can click OK. And now I've got myself a nice lofted surface, which is really cool. What else is there? Another one that's really good to know is how to merge surfaces together. So if I just quickly copy and paste this above, well, in fact, if I mirror it, if I just type in the command mirror, I can just set a mirror plane. So I've now got something like this. Let's say I wanted to connect these two edges together, but I didn't want to just do it as an extrusion. I want to create another surface that perfectly matches this curvature along. Now that would usually be something that's really complex and difficult to do. But luckily, we can do that really easily in the software. So because these are both surface objects, we're going to be using the surface dropdown. And the tool that I want is the Blend Surface tool. So I'm going to click on that edge, click on this edge. It looks similar to that loft that we just did, but when I hit enter, you see what it does. So it will basically match the curvature of the two surfaces, and it will try and blend them together. And the default settings are usually the best for this. But if you wanted to slightly deform it, you do have some controllers there, and it will still keep the curvature correct. It just adjusts the extrude distance of these curves. So that's a really nice one to know about. And of course, because these edges perfectly match, it means we could just join these together. So type in join, select the objects, hit enter. You've now got one solid object. Another command that's good to know is the cap command. So if you've got open edges like this, and if they're flat on a single plane, so if I were to view this in my side view, I can see that open edge. It's not like wonky, it's not twisted, it's just on a single plane. That means we could close this by typing in cap. So CAP, hit enter. It's now capped to the top and the bottom. I've now got myself a nice solid object. Right, just having a look in the chat. Can we import groups and components from other softwares and edit to create similar complex forms, or we need to do it in Rhino first and export the same? Yeah, you can import stuff from other softwares. That's not a problem. If you've got block objects, if you've got just standard DWGs, DXFs, OBJs, anything like that, you can import those straight into Rhino and you can play around with them. The only thing I would say is if you're importing a 3D object, typically they'll come in as an OBJ or an STL, typically a mesh object. Remember we looked at meshes earlier, the polygonal ones? And that means that you won't be able to use a lot of these commands like rebuild because they're specifically for NURBS objects. So it's one of those things you could probably bring it in and then you could use that as like a template to model over if you wanted a NURBS version. That would be the best way to go about it. In fact, another way to do it, let's say we had a NURBS mesh version of this object. So again, if I'm in rendered view, these two objects look absolutely identical. In shaded view, I can see one is NURBS, one is mesh. If I wanted a NURBS version of this mesh, let's say this didn't exist, I could just use that contour tool that we used earlier. So for instance, how high is this? Sorry, I've got a panel at the top of my screen. So this is roughly how high? 86 meters. This is a really, really big vase at the moment. Okay, that's fine. So if I type in the command contour, I could choose bottom to top, set a distance, maybe every 1000. And what that would do, it would extract all of the line work of my mesh that I can now loft together. Type in loft. Ideally, I'd want to make sure all of these are in alignment, which they are. I could click OK. And now I'm back to my object again. So again, there's ways that you could get geometry from other software to work in Rhino. You can, of course, just continue working on it as a mesh. That's not a problem. You would just have to use the mesh tools instead of the surface and solid tools. Just a different way of working. And in fact, speaking of the drop-downs, just because we've only got 10 minutes left, I did promise we'd have a quick look at the sub-D tools. Sub-D is yet another type of modeling, and it's native only to Rhino 7. It's not one that you'll get in Rhino 5 or Rhino 6. So sub-D is slightly different. You won't find the sub-D tools on the left here. You can find them in the drop-down at the top, or you can go to the sub-D tools panel along the middle, the horizontal part of the screen here. Now, it kind of works a similar way in that you've got primitives. So for instance, create a sub-D box. So I could click on my sub-D box. I could draw out a rectangle. pull it up, same as I would any other box, but this doesn't quite look like a box. If I full screen this, you know, it kind of looks like a box, but it's all kind of rounded and a bit organic. And that's kind of what sub D is really, really good for. It's good for both sharp edges and rounded edges. And essentially, it's just it's short for subdivisions. It's basically what sub D is. It's a way of subdividing geometry. Now, a couple of things you can do with this. If you've got the sub D tools palette open, you can add and remove creases. So for instance, add crease. I could click on these edges. Just try and navigate around. Click on these edges, hit enter. And you see it's added a sharp edge into these. And likewise, I can remove edges. So remove sub D crease. Maybe I only want to do it on 1/2 of this, for instance. So I could have a sharp crease on this side, no crease on this side, and suddenly I'm getting some quite interesting forms appearing. So that's one reason we might want to use sub D. I am really aware of time, so I'm going to go through these quite quick. Another reason you might want to use sub D, if I'll just bring that back again. Another reason you might want to use sub D is its ability to bridge things. So if I have these two objects here like this, I can use the bridge command. Is it this one? It's not this one. I always forget which one bridge is. This one, bridge meshes. If I use the bridge command, I can select a face. I can select another face. In fact, you need to hit enter between them. Select the first face, press enter. Select the second face, press enter. Wow, how awesome is that? So rather than having to, you know, put an object in there, like extruded between the two, union them together, fill at the edges, you can just bridge geometry now. So it's much closer to what you can do in things like ZBrush, 3ds Max, etc. It's a much more organic way of modeling. And the cool thing with this as well is you can even increase the number of subdivisions, so the number of segments, and we can adjust the straightness of this. So it doesn't look as impressive here, but I'll show you a more impressive example in a second. But it's a nice way to work. And again, you know, it's not just faces this works with, it can work with edges as well. And they don't have to be parallel. But the number of faces that you're connecting do have to match. So for instance, if I'm connecting these two faces here, I'll define that as my first set. I could tell that connect to these two faces, and that would work. That would connect those together. If I were trying to connect just a single face to two faces, it doesn't work. That's just something to kind of bear in mind. So again, can't select those. I could select a single one.
Sorry to disturb. How do you select only one box from that shape? Because I can't select that.
It should do it by default when you have the bridge command selected. So when I go on bridge, I can just click in the middle of a face and it should highlight.
Yes, it's working.
Yeah, perfect.
Thank you.
No worries. Right, I'm going to do something else. Again, I'm just trying to go through as many examples of these as I can. I'm going to show you how you can convert geometry to sub D. So if I have a circle, something like this, maybe I've extruded it along as a surface, the same way we've been modeling all morning. So curves and extrusions. If I just zoom into this. So let's say we've got something like this curve or this pipe. Currently it's an open extrusion, but maybe I want to do some more complex modeling. I could select this, go to my sub D drop down and choose the first option, from object. And what this is going to do, it's going to basically make a sub D version of this object. So I've now got an open sub D. I probably should have said I just deleted the original surface just then. I didn't mention that. But I've now got this sub D. I could now copy and paste this around. Or in fact, I'm going to show you another tool, the array polar. So if I type in the command array polar, that means I can make copies around the center point. So I can specify the center of the array. I'm going to do it down over here. Number of items, I'm just going to stick with 3 for now. Hit enter. The fill angle is going to be 360 degrees. I'm going to hit enter again, and then hit enter to finish. So that's not just for sub D. You can array anything, but it's just a nice one to know about if you've not heard of it before. But I just wanted to quickly show that bridge tool again, just to show you another way you can make it work. So let's say we've got a junction like this. If I wanted to connect these together, I can use my sub D tools, providing these are sub D tubes. I can use my bridge tool. And same as before, I'm going to select a bunch of edges. I'm going to select these 4, hit enter to define that as my first set. Select the matching 4 edges over here, because remember it has to be the same number. Hit enter. And you see it's going to connect these together. Again, I can adjust the number of segments if I wanted to. And the more segments I add in, the more control I get over the curvature of this joint. It's a lovely way to model. Then I would just do the same with the remaining faces. So 1, 2, 3, and 4. That's my first set. 1, 2, 3, and 4. That's my second set. Remember, it's the same settings as before. Now I could just continue going around and doing the same. So 1, 2, 3, and 4. 1, 2, 3, and 4. And you see what it's doing. It's not destroying the geometry at all. It's doing a really nice job of it. And if you wanted to start closing this, you could start bridging some of these faces together if you wanted to. Oops, wrong way. Set that segment down to 1. You could start closing these if you wanted to. So that way it keeps the topology of the object really nice and clean. There's also various other tools like close sub D holes. So I think it's under repair, not under repair. I can't remember where it is, but essentially you can close the sub D holes. What's the command for it? Oh, it might be fill holes actually. Fill mesh holes. Oh, I actually can't remember which one it is. There is a command that lets you close the holes. It will be under sub D somewhere, you'll find it. But it works the same way as the mesh one that I showed you earlier. It just caps each of these off and closes them. One final thing I want to show you is the multi-pipe tool, and then we're going to call it a day after that. I'm sure a lot of you are going to want to create some really complex forms. I'm going to show you some really cool stuff. And this is the type of stuff everyone thinks of when they think people like Zaha Hadid, people like that. These kind of weird organic kind of forms. We've created a lot of these kinds of things today anyway. But let's say I've just got a bunch of curves going out, something like this. I'm going to select these and type in points on. I'm just going to select a bunch of control points to move around, just to make this a bit more interesting. So moving these up and down on the Z axis. I think I moved that on the Z. No, I didn't. Oh yeah, I forgot to mention that. Sometimes when you go to click an object, it will come up with a little selection menu. This is asking you which one you want to select. If you hover over it, you'll kind of see which one it's selecting. Sometimes you need to select multiple things, in which case you can just select like that. And to deselect, you can hold Control to deselect an object. So I think that's starting to look kind of interesting. So I selected all of those points, drag those up. Let's do the same thing with this one. Pull those up. There we go. So we've got a bunch of curves, or essentially just a wireframe. And what we can do is we can use the sub D tool multi-pipe. So I select the curves, type in the word multi-pipe, if I can spell multi-pipe. I can specify a radius, and I really should have measured this first. Let me just specify the distance of this. Hang on. So that's a bit anticlimactic, wasn't it? Just because I haven't measured this to scale or anything. 116 meters. Okay, so I'm going to need a big radius for this. So multi-pipe. I'm going to have a radius of 10,000. Something like that. I can choose to cap the ends of this. In fact, let's leave that off for now. Strut divisions. I'm going to leave it as 1. And you see what it's done. So it's piped this in a really, really interesting way. And the cool thing is you can actually really control this. So you can adjust the thickness of the struts. You can make these really thin. And you could tell the thickness of each of these nodes where they intersect to be thicker, for instance. And you can create some really interesting forms. If I bring this right down, maybe 1,000 instead of 10,000. Don't want to cap the endpoints. Strut divisions I'm going to keep set to 1 for a minute. You kind of see what I'm getting at with this. You know, create these kind of alien-like structures. Trying to do something like this just a few years ago would have been such a pain to do. But I think, you know, working with this, you can create some really interesting forms. I am aware that we're already over time. We've been going for 3 hours and 1 minute. So I think I'm going to shut up now, unless there's any questions for me before I let you all go.
Hi, it's me again.
Hi.
I booked a session just now for tomorrow with you. I was just wondering, it's just half-an-hour sessions, right?
Yeah.
Okay.
Yeah, they're just half-an-hour sessions. I'll say that's usually enough to work through most things. Key thing is that as long as you've uploaded kind of any reference images or you've given us a good description, just so we can prepare, then chances are we'll be able to resolve your issue.
Okay, right. Because my description was mainly to do with Grasshopper, because I need to learn how to use the, you know, that and get used to it in terms of making facades and stuff for next week. So do you think that will be enough time to do that?
Oh yeah, plenty of time.
Okay,
Shouldn't be
great.
any issue there at all. We'll go through it properly tomorrow. We'll get you up to speed.
Perfect. Thank you so much.
No worries.
Thanks for today as well.
Oh, no worries at all. Oh, hopefully you all enjoyed it. As I say, it's a bit of a crash course in Rhino, assuming that no one has ever used this before, all the way up to creating forms like these, which are pretty complex. So yeah, kind of interesting. Any final questions before we disappear? Doesn't look like it. Right, in that case, thank you all for coming, and hopefully I'll see you next week. Next week's another Rhino session. We're going to be doing some site modeling using Digimap data. So both land and sea modeling for this one, getting your buildings onto site, getting it to scale, getting it cleaned up, the full works. So recommend you come to that one. Thanks, everyone. See you soon. Bye.